We are live in 3, 2, 1. We are live now.
Hello, everybody. Myself, Dr. Vishal Dave. I am medical advisor at Intas Pharmaceuticals, based at head office Ahmedabad. I welcome you all for this ISAR Perfection series on the topic genetics in practice. I welcome our co-convener, Dr. Monica Singh. Dr. Monica Singh is professor at LN Medical College, Bhopal. She is consultant reproductive medicine, Bhopal Fertility Endoscopy Center. She is honorary secretary, MP chapter of ISAR. She is vice president, Bhopal Obstetric Gynec Society. She is vice president, Bhopal Menopause Society. Now I hand over the session to Dr. Monica Singh. Over to you, ma'am.
Thank you so much, Dr. Vishal, and thank you, Intas, for giving us this platform to present before you the ISAR Perfection Series. This is the second episode of ISAR Perfection Series webinar. The first was on ART law, which was broadcast in the first week of March. And we had stalwarts all over India who spoke on ART law and made it clearer for us to follow the guidelines in practice and for patients as well. And the second in the series is this webinar on genetics in practice. And perfection is the title I chose because perfection means improving something until it becomes faultless and acquiring the highest degree of proficiency in a particular field. So genetics is so vast that we can't expect to reach the pinnacle, but at least we can make an attempt to see what is tangible and what we can, enhance our knowledge from it, from speaking and listening to all these experts in the field of genetics. We just know that it's the scientific study of genes and heredity and how certain traits and qualities are passed on from parents to offspring because of changes in the DNA sequence. So gene is nothing but a segment of DNA that contains instructions for building molecules and that help the body to function in a particular way. It was Gregor Mendel in the 19th century who introduced the concept. So he didn't know it was genes. He just called it discrete units of inheritance which are passed on to the progeny. But now, as our speakers will tell us, we have molecular genetics, we have epigenetics, we have population genetics, and so many tests, so many therapies that it will be a pleasure to listen to all of it. I must thank ISAR, Indian Society of Assisted Reproduction, for giving us this opportunity to present before you the Perfection series. And this wouldn't have been possible without the magnanimity of Dr. Nandita Palshetkar. Can I have Madam CV, please? Madam, all of us know, is President ISAR 2022-23. She has been President FOGSI, IAGE, all the prominent bodies of India, President AMOGS, MOGS. She is the FOGSI representative to FIGO. She has been member of various government committees related to PCPNDT, uterine transplant, surrogacy, ART law. She has received so many awards. It would be just, not enough to speak about her because it can go up in volumes. I really thank, because of her patronage only, we could do Perfection series in collaboration with ISAR. I must also thank Dr. Sujata Kar, who is our Honorary Secretary General ISAR, and Madam is in the field of assisted reproduction for the last 27 years. Her special areas of interest being PCO, male infertility, proteomics, and stem cells. She has been a gold medalist, and she is the person who gave the first IVF baby to Eastern Odisha, as well as the first TESA, frozen embryo, and laser hatched babies. Madam has received so many awards from the hands of Chief Minister and Governor of Odisha. She's had so many original publications, and she is the executive committee member of IAGE, ISSRF, PCO Society, and Fertility Preservation Society of India. Thank you, Sujata ma'am. This Perfection series cannot begin till I begin to talk about Sunita Tendulkar ma'am, because there I was 2 months back. I just had this idea in my head and I didn't know how to implement it. I didn't know how to give it platform. And it was Dr. Sunita Tendulwalkar. During ISAR also, she held my hand. And for this also, she said, Monica, don't worry. You do it with Central ISAR. I will talk to Dr. Nandita. I'll take it forward. So Madam is my mentor, my guide. Madam is also the Senior Vice President of ISAR. She is the Chairperson and Founder, Honorary Secretary of MSR, President of Pune Obsgynae Society 2122, President of all the prominent bodies of India, authored so many books, given so many publications, keynotes, orations, and received so many awards. I'm so thankful to Madam. Next for today, because and I think Nandita ma'am is just depailing from a flight. She has landed in Mumbai. So Dr. Vishal will keep her presidential address whenever Madam joins. And I will straight away go to the program coordinators, Dr. Randhir Singh and Dr. Shabana, to take us ahead. The first program coordinator is Dr. Randhir Singh, and he is well recognized because he was the dynamic organizing chairperson of 27th Annual ISAR 23 Bhopal. He's also an ASHRAE certified embryologist and the scientific director of Bhopal Fertility and Endoscopy Center. I welcome you, Dr. Randhir. And the co-coordinator, program coordinator is Dr. Shabana Sultan, who is a very dear friend of mine. She is professor in the Department of Obstetrics and Gynecology, GMC Bhopal. She's also the present secretary of Bhopal Obstetrics Gynae Society, a very active executive member of MPISAR. She has presented several papers in national and international conferences and journals. She is very keen in obstetrics, high-risk obstetrics. She is the member of the esteemed team of PPH Bundle, done international projects along with Harvard University, and she's a master trainer of cervical screening program. Here I leave the program to Dr. Shabana to conduct it and take it forward.
Thank you, Dr. Monica, for such a nice words. And I'm lucky enough to be a part of this genetics series webinar. And I'm privileged to invite our chief guest, Dr. Professor Naren Malhotra, sir. Sir, we are very happy to invite you as a chief guest of this Perfection Series Genetic Webinar. Sir is Managing Director, Global Rainbow Healthcare. Sir is Director, ART Rainbow IVF. Sir is Director, Foxy Smriti Maneta, Director, Project Positive Health Rotary. Sir is National Director, Ian Donald School of USD. Sir is Professor in Sergivo School of Science and Technology. Sir was past President of SAFOG and WAM. Sir was past President ISAR, ISPT, IFUMB, Foxy, AUGS. Sir is advisor to Maulana Azad Medical College, New Delhi, JNMC, Aligarh, and SMS Medical College, Jaipur. In his credit, for more than 300 chapters and more than 500 presented papers, over 1,000 guest lectures in India and abroad. Sir has 56 oration and 37 published papers. He is editor of 59 books, many chapters, and series of step-by-step books in revising editor of Jeff Cott, revising Ian Donald. And we are very lucky to have you, sir, as a chief guest. And sir has various awards to his credit. I'm also lucky enough to invite Dr. Amit Patke, sir, as a guest of honor, and he is President-elect of ISAR 2224, Medical Director Fertility Associate Mumbai, Honorary Associate Professor S.J. Somia Medical College and Hospital, Consultant Khar Hinduja and Surya Hospital Khar Mumbai, Country Representative Aspire 21-23, Governing Council Member ICOC 2012 and 21, President-elect SR 22-24, and General Secretary MSR 2018-21. And he is also having so many publications and more than 50 book chapters and various international and national awards.
Now, Dr. Shabana, I think we can have a few words from our chief guest and the guest of honor, if you permit. I think Dr. Shabana is having some connectivity issues. Dr. Malhotra, sir, we would be honored if you could start our genetics program with a few
Patki,
words.
sir.
Yes, a few
Yeah.
words of encouragement, sir.
Dr. Malhotra, sir, welcome, sir, to this webinar. A few words for us, sir.
Hello, everyone. Good evening. It's indeed a pleasure to be here associated with yet another unique program of ISAR along with Bhopal Gynec Society. Congratulations, Radhir and Monica and Shabana for organizing this wonderful awareness program on genetics. You know, we obstetricians have to know a lot of genetics. We still have to learn what are genes and at least the basics, and at least what tests are available and what tests tell you what. Because a lot of times we just write karyotype without even understanding what information it will give and where karyotype should be done, where microarray should be done, and where sequencing should be asked for. So before we know the test, you have to know what is behind me. So you have to know that our body is made of 44 plus 2 chromosomes, and that autosomes and sex chromosomes. You have to know these chromosomes. As you can see, this one has DNA wrapped in it. And when you unfold that spiral DNA, you have nucleotides joined, which are those lines. And those are 4 amino acids, nucleotides, adenine, thymine, guanosine, and cytosine, which are the AGTC. And that depends how your genetic material or how your proteins will be synthesized and how your genes will get activated. We also know that we have 30,000 genes, and not all genes are good. A lot of genes are rubbish. And all of us carry all types of genes. So we carry the good genes and we carry the bad cancer genes also. So there is where your epigenetics works. So epigenetics is something which is outside the genes. Now that's our environment, what we eat, how we behave, and that activates the good genes and you are healthy. And if it activates the bad genes, then you are unhealthy. So you can get your whole genome sequencing for just 20-25,000 these days and know what disease you're prone to. And you can probably take some action, preventive action or antioxidants or whatever. We are still not very near on gene therapies and gene transfers, but CRISPR and all is there, and we can edit genes and can make embryos free of diseases like diabetes and the others. So that is coming, and it is already there above the experimental stage. So clinically, it should also be with us very, very well. But what we need to understand, all of us, that what we look like is our phenotype. What our inside is our genotype. And each cell has 46 chromosomes, 44 autosomes, and 2 sex chromosomes. And we have 30,000 genes. And each gene has 2 alleles. And these 2 alleles may be same. So it is homozygous. They may be different. So it's heterozygous. One this and one that, and half same is hemizygous. And this is what translate into health and disease. And before we do, so supposing you have a genetic problem baby born, so you need to learn how to draw a pedigree. And that pedigree charting lecture also is very, very important, which probably I'll be taking in Bombay of those who are there on 27th of May, how to chart your pedigree. So the square is a male, the round is a female, single line is married, 2 lines is consanguineous, and then if it is abortus, if it is dead, dark colored, single colored, and all that. So we need to know that. That is how you can trace the genetic inheritance to up and down. So that is very, very important for all obstetricians to know that. Then it is very important for us to know that chromosomal anomalies, what type of chromosomal anomalies can happen. So in prenatal diagnosis, when the birth in pregnancy, there are 5 of them which will be Edward-Patau, Down syndrome, Klinefelters, and Turners, and some variants of super female and all. So don't test for chromosome 1, 2, 3, 4, 5. unless there are repeated abortions. And type needs live dividing cells. So you ask for microarray, and that is how, or you ask for genome sequencing, and then you will be able to know that this tortoise had which chromosome defective. Robertsonian translocation, whatever it is, and what we can do and what we can counsel. So this
Is our technical team? I think there is some network problem. Please.
Yes, sir. I guess Dr. Narendra sir is facing some technical issue over there.
From your side, there is no problem.
From our side, sir, there is no problem. I
Sorry,
guess
I
he
got
might be having some internet issues there.
connected. Once again, congratulations to all of you.
Malhotra sir, there is some audio problem, sir. We are not
For
able to hear
organizing
you
this.
properly.
All the best for this webinar. Thank you for inviting me as chief guest.
Thank you so
Thank
much,
you,
sir.
sir.
Now I invite Dr. Amit Bhatke, sir. Sir, please enlighten with a few words.
This is Priyanka Rangani. She's 35 years old, married since 9, trying some.
Randir, sir is there or not?
We didn't see him joining, madam.
Okay.
Okay.
So I think I'll. You can proceed. Just I'll think. Then we can start. If Dr. Monica, you can have a call to him. Amit Bhatke sir. Ashish, he did not join.
No, I not seen him joined there in our group.
Okay. Then I think
So,
we can.
yeah,
We can.
We'll
Yeah, we
move
can start.
forward to
Yeah.
the first session. I welcome Dr. Sunita Tandulkar, ma'am. And now we move forward to the first session, that is talk on stem cell in infertility. And for chairing this session, I invite Dr. Pratik Tamis, sir. He is ART consultant, gynec endoscopic surgeon, Ashirvad IVF Mumbai, International Diploma in Advanced Laparoscopic France. Is chairperson AMPOX Endocrine Committee 2020-24, Governing Council member, Indian College of Obstetrics and Gynecology 21-23, patron and managing council member, Mumbai OB-GYN Society, and managing committee member, Indian Society of Assisted Reproduction. He is recipient of 30 MOGS, MPOX, and SARS-C prizes.
Thank you. That should be enough.
And many awards. Credit. Welcome, sir. And the
Thank you, Dr. Monica Singh and the
Dr.
NTSR team for inviting me.
Thank you, sir. Second chairperson for chairing the session is Dr. Ashish Kale, sir, and he is Director, Asha IVF Center, Director, Asha Hospital, Pune, Foxy member-elect Committee Chairperson, Welfare Foxy Society, Secretary, Pune Obstetric Gynae Society, Clinical Secretary, SAR 22-24, Executive Member, IAG 2018-24, and he was Vice President, POGS 2018-2019, and recipient of
Thank you, madam.
Champion of the SAR and various publication and award to his credit. So I welcome both chairperson and I hand over mic to you, sir, for inviting speaker and introduction of a speaker. Thank you.
Thank you, everyone. For first of all, I'm thankful to our president of ISAR and secretary for involving us for this particular webinar. As all of us knows that Dr. Narendra Malhotra sir already talked to us what is the importance of the genetics in current practice, and to say a few words about the session today. We are going to have the stem cell therapy in infertility, which is going to talk by our like my own past president of POGS, Dr. Sunita Tandulkar. She is a senior vice president of ISAR, and she is founder or honorary secretary of MSR, president of IAG, past president of IAG, vice president of West Zone Foxy in 2015 and 17. But apart from this, if I can say a few words about Madam, I seen a determination and I seen a discipline in her and commitment. So whenever she commit to any of the, even if it is a conference or even if it is a webinar, she puts 100% into it. And she's going to the Foxy elections in a few months. And I wish her best luck from our side. Over to you, Madam, for your brilliant talk. I think Dr. Amit Patki is joined. I request Dr. Amit Patki to say a few words about the webinar.
Amit, you
You
are
are
muted.
Okay. So a very good evening to all. And at the onset, I would like to congratulate ISAR President Dr. Nandita Palshetkar, Secretary Dr. Sujata Kar, and the convener for this program, Dr. Monica and Dr. Randir, for coming up with a very interesting name for the series first, and then to start off with genetics and genetics in infertility. I think it's a fantastic idea. And I don't think we could have had a better speaker in Sunita Tandulwarkar. She has done tremendous work, extraordinary work in stem cells. And I'm sure she's going to have some very big announcement for us, besides a Foxy election, about how she's going to take this stem cell forward, not only in our country, but internationally. So my best wishes to the series and best of luck and congratulations to Dr. Monica and Dr. Randir for yet another excellent series from ISAR. I think ISAR is offering a large amount of a rich scientific extravaganza spread over the month in various topics. So best of luck. And I'm sure this will have a wide coverage. Thank you very much.
Thank you, Amit sir. Thank you.
Thank you, Dr. Amit. And I must say, because Madam is here and you have said this series is a brainchild and child of Dr. Sunita Madam. Because of her only, it could reach all over India, and it has come forward with the endorsement of ISAR just because of the efforts of Dr. Sunita. We wish her all the best for the Foxy elections, and we want to see her as president of
And we are all on her side, and I think we each individually of us should talk to at least 20-30 people, because I think she will go beyond the bars that have been set in Foxy. I've seen her work so hard, and I've seen her move around, and I'm sure success is what she deserves.
Definitely, sir. Definitely.
Bilkul, sir. Bilkul. Amit sir, you have told the truth in advance. Nobody can see the future, but I can see the future. There is no competition for ma'am.
Thank you so much. You are my true friends. That's why you are saying winning everywhere. Amit, thank you so much. I know how openly you talk about me and you support me, and I see everyone here, Pratik, Ashish, Manoj, all my great supporter. Oh, Manish Pandya is here, my younger brother. We came to know that he's younger to me. Since that time, I make him work more than what he would have done. I found out I'm 2 years elder to him. Narendra, wonderful, you are here. He is my, the biggest strength across the country. Anything I need, I just give one phone call to Narendra, and Narendra is there. So thankful to you.
Including WhatsApp problems.
Yes.
Thank you so much, Narendra, always for being there with wonderful ideas. I think we are live relay. So let me start with the talk on stem cells. And Narendra, I'm going to give you a call after 1 hour again. Thank you, Randir and Monica, the very hard-working couple. I think they are the asset for ISAR. Everyone has seen the rocking Bhopal ISAR, the amount of efforts this couple has done, and it was so marvelous. We all still have a lingering memories of it. And namaste, everyone. Whenever it is a stem cells, I dedicate this lecture to my mom, because of whom I have entered in the stem cell. Let me be honest enough to tell, if I would have been just the ART consultant or an endoscopist, I don't think I would have entered into stem cells, because stem cell is a huge science. We have a patient, we don't have a knowledge about it. While scientists have a knowledge, they don't have a patient. And unfortunately, in India, we don't have enough money to invest into the research and work together. It's my mom who was on a deathbed because of the kidney failure and not ready for dialysis. I wanted to regenerate her kidneys and I thought stem cells, and believe me, 6 years she lived without dialysis. Now, during that period, what I learned about stem cell is stem cell has a huge potential. See, you have a specialized lab. You have prepared the cells. Now what happens is you have no choice than keep on reading about it. And you realize that it has huge potential. By that time, your team members, may it be neurophysician, may it be ortho, may it be GI, they start working and you see the tremendous potential of stem cells to regenerate any organ you put into. And that's how 2015-16, I think I'm hardly read anything on endo and ART. I was reading only on stem cells. And today I'm taking you to my experience about stem cells. Friends, advances in science always for the betterment of a human being. I strongly believe it, and it is very important to modify and change one's idea as the science advances. Now, will stem cell revolutionize ART treatment? Where do they stand? Today, I will be talking, because it's just 20 minutes, I can't cover whole. I'll talk only on a female infertility. Keep your mind open. Unless it's open, you will not accept. Though I feel 3 years ago, when I used to give a lecture on stem cell, everyone used to say, think or see to me in a misbelief. I'm sorry, I'm sitting in a clinic which is like a bazaar happening. So the stem cells today, even with our own gynecologist and with the patient, it has become an acceptance, because it is written by the digital media, by the social media so much that today it becomes easy for me to talk about the patient, about the stem cell. But one thing, let me be honest and tell you that stem cells are still under research. It has not come to the category of therapy. So what are these stem cells? The body is made up of 200 different types of cells. All have come from the stem cells. A stem cell is a cell which is not specialized and has a capacity to specialize into any cells. May it be muscle cells, may it be nerve cells. I think Pratik Tambe is talking, he's not muted. Fat cells, skin cells, or any cell. And the process of specialization is called differentiation. Now, once it gets differentiated into particular cell, like muscular cell, it cannot come back and become a nerve cells. So this process of specialization is called differentiation, and then it is always irreversible. Now, these unspecialized cells capable of renewing themselves through the cell division, and they have a capacity to form the organ. Today, we take out the stem cells, for example, hematopoietic cells, and we grow them in the incubator. We separate the mesenchymal cells. We culture them for 2 weeks, 3 weeks. We create the osteoblasts from them, because the orthopedicians have entered in a massive way into stem cell. Why? Let's talk about the ovarian reserve. We all know that 10% of the women undergoing IVF has a decreased reserve. I feel this is Padmarekha Jirge's publication in 2016. But today in 2023, I'll definitely see 15% of the patient, and those who are doing specialized ART clinic, I'm sure 30 to 40% of their patient is always with the decreased reserve. Now, we don't know the cause. Let's not go into the cause of that. But what is important is the ovarian rescue, repotentiation. It is an elusive term, but whether it is possible or probably it is possible. If you see the literature from 2004-5, Johnson & Johnson group, they first worked in the animals, the mice, and they saw that those who were sterilized with the chemotherapy, they have been helped by the autologous bone marrow as well as by the peripheral blood. And then these several independent groups, they have said that the autologous stem cells can differentiate into primordial germ cells and then the haploid gametes. In these last 20 years, so many publications in various journals, and they said that there is a considerable evidence that germinal stem cells can be created and can help to colonize the follicles, and folliculogenesis can be established. Now, we need to harness the stem cells. We have to mobilize. How do we do this? This is what you're thinking is you need, initially in 2015, I used to take out only 100 cc of bone marrow. Today, as the time moves, our understanding of the subject also increases. We see more and more results. So we take out now 150, 200 cc of bone marrow. In young patient, it comes like in 10 minutes we take out. More the bone marrow, easier it will be for us because per cubic cell concentration of the stem cells will be high. And we have been given DCGI and FDA approval only for hemopoietic. I think in 2-3 months, we will be entering into the adipose tissue also. I think it's my Foxy election, which is stopping my entry into adipose tissue because I want to come in a very big way into the adipose tissue also. So what you think? Always sit with the pen and paper. I have the stem cells. I have the poor ovarian reserve. Can I do and inject and stimulate the ovary? I was told that the pancreatic cells can be hepatic cells. The cartilage can be created. Then your study starts. In journals or anywhere, it is written that they do transvaginal sonography. On transvaginal, these are very atrophic ovary, very difficult to fix, especially if the patient is 75 plus. They are so high up, and in a sonography, you probably get many a time 2-dimensional figure. So you start thinking what you can do. And probably I have done the studies where I realize if you can put it into the subcortical region. So these cells are more present in the subcortical and not into the medulla. So you need to do the subcortical very well injection, and we do it laparoscopically. So initially, our own experience, we have always put up. Now I'm lucky, I think, when we published our first paper and we submitted our India's first stem cell baby, we got a later email from a journal asking for writing a review article. And when you read the review article, you read in depth all. And we realize the inclusion criteria of all till 2018. Now, our publication came in 2018, but we were studying in 2017. Inclusion criteria were 40, and we changed our title. It's very difficult to do anything world record, and I'm so glad that I got a chance to write a review article. The girl who studied and came out that everyone is 40 is Shreya Gupta, and that's why I wrote her name first. I need to give a credit to her. Just last week on 16th April, we celebrate the 5th birthday. My patient and her daughter, both are in Dubai. Every year till now, they came to India to celebrate the birthday week. And by now, we have a huge citations in all the journals and innumerable citation for it. So this is Sanket's needle. And we were injecting these days. There are various. Now we evolved with our technique. You won't imagine over the period we created so many needles, even the grasper where the needle can go in centrally. We cannot use our egg retrieval needle. It is beautiful. It has so many holes at the tip, but it is too thin to enter into the ovaries many a times. So now we have a specialized needle which we inject, and we take a caudal end and a cranial end, and we do 2 on a superior aspect, 2 on an inferior, and 1 on the lateral aspect, I avoid entering into the hilum. So now our technology is finalized how we do. But believe me, for 2-3 years with every patient, I used to sit and I used to do this type. We used to write this patient, we injected in this way, and we used to see the results. But now, with the time, you evolve and you finalize one technology with which you will be going. Friends, challenges are what make life interesting. Overcoming them make it more meaningful. Our further experience, we took a 20 cases data. Always with the bone marrow, we have used PRP from the day 1. December 2015, we did for my mom the first case since that time, because platelet-rich plasma is known to cause activation of even the bone marrow stem cells. So we always combine PRP with the stem cells, and we did our 20 cases study and we published it in 2020. Our aim was to assess the safety and efficacy of intraovarian. We have taken Poseidon group 3 and 4, and we have found that it is safe. It can optimize the recruitment, but in 65% only we got the result. In 35% we did not got the result, and we don't know why. Their inclusion criteria, exclusion criteria, all were same. Friends, we always exclude genetic disease. You have to rule out Mosaic Turner. You have to rule out Fragile X syndrome. I think in his chief guest address, Narendra spoke so beautifully in 3 minutes about this genetics, and every one of us has to know. Of course, we should have a geneticist in our group, because we can't go and do this all pedigree and all. If we have someone handy, it becomes easy. But we should have a sufficient knowledge, because more and more complicated cases, those who are doing ART, they know that they have to do pre-implantation this thing. So darkness to knowledge, we are moving on towards, but still our knowledge, we are dark in few things. One, when the effect will be seen. I have done the stem cell. Am I supposed to see the patient after 3 weeks, after 6 weeks, after 12 weeks? How long the effect will last? So I have done IVF for all my patients. In a literature, they have found they are allowing the conservative, the time relation for this. But I don't have a knowledge how long they will last. So optimizing their result, pulling the eggs as much as I can, and giving the success with the IVF, because IVF definitely will have higher success rate than the natural fecundity. And that's why I've gone for IVF. But in 35% of the cases where we did not got the result, we had no choice than to explain the patient that you keep on trying your relationship. When to keep relationship, how pregnancy happened, we discussed. And friends, we got 2 patients conceived. Again, we have published this data, because it is important that we all publish whatever work we are doing. In India, there are 7-8 people who are really doing a genuine work. Narendra is one of them. And we have to tell our colleagues that one I got after 18 months natural conception, one I got 22 months natural conception. By now, we have 2 more patients. One got conception in 3rd month of stem cell. She went for a vacation for 4 months, and then after coming, she was supposed to do IVF, but she conceived naturally. So natural conception do happen. Platelet-rich plasma, I'm not going to go in detail. We all know that platelet-rich plasma have all numerous cytokines, growth factors. For example, a lady who ovulates every month, you do the laparoscopy, you don't find any adhesion, sign of a injury or a wound on the ovary, because natural healing happen, and that is because of the platelet release factors, which causes tissue repair. And it has been said that intraovarian injection of that can recruit. The problem is whether the studies with the PRP are not for a longer period. They have to work more. Now, 2018, when we published our autologous platelet-rich plasma along with the PRP, during that time in August and I think in Jan, 2 papers got published only with the PRP, and they said they have quite considerable good result. Even the Silis has done a good job, and his patients were above the 42 age group, where in all the 4 patients, he got a pregnancy. The concern with the stem cells or the PRP is we have many pieces of unclear puzzle still. With the PRP more, because its effects are less known, and if it is going to activate the stem cell, will it trigger the tumorogenic or malignant transformation? And whether this patient 10 years down the line will come in my cabin that I have malignancy, I'm not aware. So I always explain the patient, listen, you got the baby, your one is part, but yearly doing your sonography and the ROMA is very important, the tumor markers, because I'm not aware what we did in your ovary is going to give any long-term consequences. It's better we explain the patient, take her audio video consent and keep her on a follow-up with us so that we don't fall into trouble. This is what I was talking about, the Silis article with 4 patients, all 42 age group, and he got couple of blastocysts with them. Every lady has the right to have her own genetic baby, and I think stem cell may help them to fulfill dream, at least to some women. What about the refractory endometrium? If you can regenerate the ovary, why you can't regenerate the basal endometrium? So platelet-rich plasma for a thin refractory error, I'm not going to talk about it because this is not my topic, but 2017, again, the first publication from India, where my entire team of 60, I think that time the cases were 10 cases and 12 cases. Ours was relatively large sample size of 68 patients with study up to 60, up to second trimester of pregnancy, and we have many citations with us on this PRP also. But what about the bone marrow? PRP is not going to get you basal endometrium. What is I have complete obstructed. This is an internal os. Any endoscopic surgeon with their great skill can create the cavity from a pinpoint os to beautiful cavity. This is quite routine. Every one of us are doing. The problem we used to face is, how do I maintain? Only estrogen, progesterone are not going to help me. And again, the thought process starts working and you start thinking. So this is obliterated. These are the patients where I use a stem cells. So I'm doing an adhesiolysis. Of course, endoscopic surgery and ART field has come to my rescue. If I would have been a routine OBGYN and entered in a stem cell, again, I feel I would have been handicapped to use those stem cells in gynecological condition, because you definitely need your endo ART to help. Now I'm doing the adhesiolysis, going very slowly. I don't want to perforate. I perforate, I spoil their career, obstetric career, of course. And tuberculous uteri, they are very small, atrophic. What I was happy to see this cavity or the corneal opening for 2 reasons. One, it was not obstructed. Half the cavity was obstructed, but the corneal opening was not fibrous. It means it's not such a bad case. Second, I have reached to the end stage of the dissection on that side. So this is a half fibrous cavity, not at all good looking, no endometrium at all. And this is a beautiful cavity. So we did subendometrial. Now subendometrial means there is no endometrium, but just go 2 to 3 millimeters down and inject the stem cells. Again, for an autologous bone marrow, now we got our standardized technique. And after 4 weeks of a estrogen and progesterone, look at this cavity. One, the white fibrotic cavity is pink cavity. I'm very happy. I can see the flecks of endometrium at places. This patient also had a scanty menses. And what is important is I can see the corneal opening. Can you see that? The corneal opening without entering. So you always do the pilot office hysteroscopy. Don't dilate. Otherwise, you will break these fibers with your dilatation and you will not come to know. I can do now further adhesiolysis. This is a hopeful cavity. You see how from right side, the endometrial flecks are floating in. It's fantastic. Now, these are the cavity which are hopeful, but not necessarily you get these cavities every time. If I get the cavity, what I started back when the first sitting, I will definitely sit with the patient and tell, I can try one more sitting, but probably I have a less hopes with this. Frankly speaking, friends, this is not my first case. During COVID pandemic, in 4 years, we had more number of success with endometrium than with the ovaries also. But our all cases, computer got dislodged. We never used to enter at each other's cabin and sit others. The few fellows have finished even without touching the patient, and they moved on. The data got misplaced. So when I told my new fellow Sneha Mishra, let's publish this case, she said, but this is not our first case. I said, that's okay. 10 years down the line, when we will look back, at least we'll know that 2020 we published our data. Otherwise, we will not be able to publish. We have more cases, only you and me know. Unless we publish, we don't have a evidence, we don't have a proof that we have done more cases. So your first case for the world is this case. Friends, if you don't challenge yourself, you will never realize what you can become one day. There are ethical concerns. We are working very hard to keep ICMR out. At least I got NAC SCRT. I got my ethical committee on Saturday when I was on a stem cell in international conference of all the faculty. I was one of the invited faculty. And I came to know AIIMS also don't have NAC SCRT yet with them, because ICMR doesn't give. In 2018, I got ethical committee approval by ICMR. Everyone told me you are lucky to get. But DCGI worked with methodical, and DCGI worked with the speed. Within 1.5 years, even if it was a COVID pandemic, mid-October 20, I got this DCGI permission. So friends, always think that one life is not enough to learn everything and to do everything. Never think you are on the top of the hill. There are so many hills to climb, and it's important that we keep on learning with our team members. We keep on choosing the path less chosen, so that we can just keep some footprints on this earth before we leave the world. Always, I believe that science is not only compatible with spirituality, it is a profound source of a spirituality. I see that the patient who come with the faith that, yes, stem cells are going to work, I get the results. I don't know. It's their positive thinking. What you think God gives you. God always, universe says you tathastu. Friends, before I end, let me appeal my all dear friends, the chief guest, the guest of honors, and my chairperson. Everyone has already spoken about it, and I definitely need your blessings to tell the universe to say tathastu to my friends. Thank you so much. I always like to thank my team members. It is the team who teaches you, who mobilizes you, and who makes you work more than what you can. Oh, I see Rosa.
Hi,
Thank you so much. Thank you so much, dear. Hi, Pratik.
Thank you, madam, for a fantastic talk. I think it's always illuminating to listen to you. Every time I listen to one of your talks, I learn something new. And I've been listening to you for at least 15 years now. You know me since the days when I actually had hair on my head.
I know. I can create your hair. I know you are not interested.
Stem cells. Thank you very much. So an amazing talk by an amazing and legendary personality. We're really privileged to have Dr. Sunita with us. And as she illustrated, she has the permissions which very few people have regarding stem cell research in India. She also has a whole list of firsts to her credit, including the first stem cell baby which was conceived in India. So we are really privileged to listen to her today. Thank you again, Dr. Monica Singh and the MPSR team for having me here. It's always
Hi, Vishal. Hi, Deepankar Banerjee, sir. How are you? Thank you to see you.
Thank you.
Anita, madam. Lovely to see you, Manoj.
Best wishes for your presidentship.
Good evening, ma'am. All
Thank
the
you,
best,
sir.
ma'am.
Thank you. Thank you.
As
You know,
usual,
I
nice talk,
love
madam.
this Zoom. See, otherwise, कहाँ दीपंकर सर को और कहाँ विशाल को मिलती?
If
Yes,
I
sir.
can say something, Pratik, that what I really like, Dr. Randir, hello, how are you, Monica, of course,
Fine, ma'am.
you here. What I really liked in the talk, besides, of course, Sunita is a great academician. I have visited her stem cell, clinic, and she's doing excellent work in fertility endoscopy hand in hand. What I really admire in her is a sense of spirituality and morality that she has, putting science and spirituality together, which is, I think, the need of the time for all of us. I think one of the ways, Sunita, you've been successful in all your work is the faith you have in God. And you create that in your patients, which is one thing I myself have followed working with you. I've been attending your clinic. I know what you're doing there. So that is something which is really admirable. And I follow the same principles of spirituality and morality.
Thank you.
Sorry,
Two things. I see Nandita joining the webinar. And Rosa, it was lovely 1 week I spent with you. Rosa and me stayed together in Pune, and she just came to see the work what we do. Hi Nandita, the ISAR president has come.
Yes, ma'am. Welcome, ma'am. Nandita, ma'am.
Nandita ma'am, most welcome.
Ma'am,
to
unmute
Star
yourself,
Perfection
Nandita,
series.
ma'am.
Nandita, ma'am, unmute yourself, ma'am.
And madam is, I think, just deplaned, and she's at the airport, and she has been kind enough to come to the Perfection series and bless us.
Yeah. It's, I think, Sunita, congratulations. You must have, as usual, delivered a fabulous talk. It's your pet topics themselves. But at the onset, I think, as the ISAR president, I'm very lucky to have fabulous people who are doing some fantastic work. Monica, I can go ahead, right?
Yes, ma'am. Yes,
I don't know what. Fantastic work, and I'm very happy to have Monica and Randeep doing this Perfection series. This year, it is on genetics, and we are very happy to have. Genetics is something very important, and it is the upcoming field in IVF, and something which is going to be the field of the future. And today, when you have talk which is explaining the basics and then genetics in infertility and PCOS, I think that is really important. And I'm really, really glad that ISAR has taken it upon itself to explain to its members the importance of this field. So congratulations once again, and I'm happy, Monica, that you've taken it upon yourself. This was something that I really wish to do, and with this series, we are going to do this. And Sunita, thank you for spearheading this series along with Monica, and all the best. And thank you everyone for being part of it, and all the best. All the best.
Thank you so much for giving this opportunity, Nandita ma'am. If it was not for you and Sunita ma'am, we would not have got the endorsement of ISAR and such a big viewership. It was really sweet of you to say yes. Thank you, ma'am. Thank you so much.
Madam, yeah, madam. Again, then the guidance of you and Sunita ma'am, we want to continue the flag of scientific to the top of the world. That is our aim.
Thank you so much, madam.
Thank you, Monica. Thank you.
Thank you, ma'am. Thank you, ma'am. Dr. Shabana, I think we can proceed with the second talk. After the fantastic talk by Dr. Sunita ma'am, who is speaking all over India, working so hard, and in her we see our future president.
Yes, definitely. So we move forward to the second talk that is more interesting, that is demystifying genetics. And to chair this session, I invite Dr. Rosa Ulaya, madam. She is director of Ulaya Hospital and Research Center. She is board membership committee, Family Planning Association of FPAI, chairperson SBC Madhya Pradesh, representative board of trustee, South Asia fellow and member boarding governing council India of OB-GYN, vice president FOXI 2014, chairperson adolescent health committee of FOXI 2012. In her credit various awards, DC Datta Award and Mehru Dara Hansotia Award, and she has lots of many publications. I welcome you, ma'am, for chairing this session. Our next chairperson is Dr. Anita Shrivastava. She is President of Obstetric Gynae Society, Bhopal. Postgraduate from Government Medical College, Jabalpur. Working as an associate professor in Chirayu Medical College. She was vice president, past vice president and secretary, joint secretary of Bhopal OB-GYN Society. She is trained in advanced gynecological laparoscopic surgery, senior consultant at Chirayu Medical Private Limited, Bhopal, and her special interest in routine obstetric high-risk pregnancy, adolescent health, and cosmetic gynecology. I welcome you, sir, madam, for chairing the session. Over to you for inviting your speaker of the session. Thank you.
Okay, thank you, Dr. Shabana, for the kind words. By the time I get the resume of the speaker, I would like to congratulate Dr. Monica Singh, Dr. Randir Singh, to have been really doing such great work and bringing together such important topic like genetics. And I think it's very important to have speakers where I can see Dr. Shashi Srivastava, Dipankar, Dr. Banerjee from Jabalpur, a lot of, other known faces here, which, they're on the dark right now. Vishal, I can see. Anita, I can see here, who's co-chairing. So to come to the session, which is going to be yet another interesting session, is Miss Joelle Bose Pandey. She is, of course, ESHRE certified senior clinical embryologist. So we have an embryologist with us. Monica, good, you brought all kind of faculties together. She has been the course director and trainer at Embryogeny, former product architect at the CSC Technology. Special interest is in nuisance of blastocyst culture, genetics, and use of AI for IVF, lab automation, web designer, CEO specialist, and an avid blogger. That's very nice. You're quite talented. I think there's a lot of things that you have done, and you're also part of the MPSR Executive Committee member, life member of many institutions, and you have contributed to a lot of articles. So good to have you in our bag. Monica, well selection of speaker. So I think your talk is going to be absolutely interesting for the audience. So let's know what is about a beginner's guide to DNA and genes, and who better than you?
Thank you, ma'am.
Please go ahead.
Yeah, I need permission to share the screen. Okay. Is the slideshow visible?
Yes, it's very visible. Yes.
So thank you so much for the kind introduction, ma'am. And I am Joelle Bose. And today I'm very happy to be speaking on a topic that I'm very fond of. And special thank you to Monica, ma'am, for having faith in my abilities. I am definitely not an expert in genetics, but I am definitely a most recent student into genetics. So I have learned, self-learned genetics, and I know what it means to not know genetics. So like Monica ma'am in the beginning of the lecture mentioned, that genetics is much more beyond inheritance. What we were taught in our school and all is more focused towards the inheritance part of it, but genetics is much more than that. So without wasting any more time, let us just quickly get into what we'll be covering today. We'll try to get into some basic definitions of what Narendra Malhotra sir also mentioned, nucleotide, DNA, chromosome, genes, what are the differences, what they are exactly. We will get into cytogenetics, structure of a chromosome, chromosomal errors, ploidy errors, numerical errors, and so on. And then to genes and genetic mutations, parts of gene, allele, mutation, and type of mutation. And due to the lack of time, I'm very sure I won't be able to finish it within the allocated time. I will not cover epigenetics today. It is actually a lecture on its own. All right. So let us first see what we have here. We start with the basic 4 nucleotide base pairs, adenine, thymine, guanine, and cytosine. These are DNA molecules are made up of these 4 basic building blocks. So they are represented by the letter A, C, T, and G. When we add these building blocks, when they come together in a classical double helix structure, what you see on the left of the screen is the double helix structure of a DNA. And when you break that double helix structure and put in a simplified form, then on the right of the screen is a step ladder model of the DNA. These are the 4 building blocks, and seeing it in animation, we will see that, like all of us know, that DNA reside within the nucleus of our cell. So each nucleus has, I'm sorry, I just need to get back. Okay. All right. So in the animation, I'm trying to show that the long linear chain of DNA has genes on it. These linear chain of DNA are wound around histone proteins. And this entire structure is called a nucleosome. These nucleosomes, when they come close together in a compact structure of a solenoid, they look something like this. And this compact structure, when further is compacted on a protein scaffold, it looks like a familiar structure of a chromosome. This structure of a chromosome is visible only during cell replication and division. So seeing an animation of this gives a better idea. So this is a linear strand of a DNA. We have 1.8 meters of DNA in the nucleus of a cell. The purple body is the histone protein. These histone proteins are just finding them and spooling them into a compact structure of a solenoid. And this is then sitting in a further compacted model on a protein scaffold to form a structure which looks like a chromosome. So what we see under the microscope is a chromosome, which is nothing but a highly compacted structure of this entire DNA. Now what you see on the screen is the segregation and pulling the chromosomes apart into daughter cells. So this is what you see on the screen. So if I have to use an analogy to explain what all of this is, then the letters A, T, C, and G, they are the 4 basic building blocks. And if the entire human genome can be considered as a book of an instruction manual, then these 4 nucleotides represent the letters. And when these meaningful set of individual letters form words, and these words form a meaningful sentence, then it forms a gene. And these genes, when they are, these sentences, when they are kept in proper spacing, proper paragraphs, then it forms a chromosome. So if this is a human genome book, then the chromosomes are individually a chapter, and each chapter has linear strands of nucleotides, which are then arranged. And a meaningful set of this nucleotide is a sentence, which is a gene. To understand the concept of a central dogma, what are we trying to do with all of this genetic information? We have to understand what is a protein and what it is made up of. So amino acids are the basic building blocks, which when they are joined together in a particular sequence, they form a polypeptide chain. And this polypeptide chain, when due to various attraction of various molecules and side chains, they form a particular 3-dimensional blob-like structure, which is nothing but a protein. So one protein is made up of many polypeptide chains. The central dogma says that DNA, like what we see on the screen, the information passes from the DNA, which resides within the nucleus, and from the nucleus, this information comes out using an mRNA strand, and it comes in the cell's cytoplasm, and there it assembles all the amino acids and creates a protein. So the point is, why are we trying to understand all of this? The thing is, we know that we have certain building blocks which are present within the cytoplasm as amino acids, but the instruction to code for that protein is present within the nucleus, in the form of a DNA. Now, we will see how this happens through the process of transcription and translation. For this, we need to first understand the concept of a code.
Doel? Doel, can you, I think she's
Lost her connectivity.
Yeah.
I think she'll join. She's very smart.
But it's amazing, Monica,
Yeah.
what topic.
Man, we have
She's
some
an engineer.
we have some geniuses in the group. She's one of them. I'm
Yes,
just
yes, ma'am.
Yes, she is one of the geniuses of ISAR also.
Yeah,
So
yeah, ma'am.
I just picked out those diamonds, I said, everybody
Absolutely.
should see them. Yeah.
It's amazing to hear and learn. Of course, some of it goes a little beyond our head, but no, it's very important for us to know because now genetics is into the, realm of stream of knowledge. And there are so many things going on with genes preparation. Sunita's talk was amazing. Absolutely. Very good selection. Randir, congratulations. I see you
Thank
there.
you, ma'am. Thank you, ma'am.
It's good.
Monica, madam,
Yes, Manish.
when she joins, we just say that when we see or we talk about gene, it is TACG. So take around the God.
Yeah, take around.
TAC and G.
Yes.
It is the take of God in all the genes.
Yes.
So you see, we are made up of all 4 TACG.
Yeah.
So we can say it as a tech C or tech G.
Ah.
So it is the technology of God, and we are made of all these different genes.
Manish, absolutely. It's so amazing to see what God has created. Amazing, amazing. I think there are other speakers also. Dr. Deepankar Banerjee, I can see him here.
Yeah, just I talked to Doyle. She's just coming, rejoining. There was some signal problem.
There
So
is a
you're
connectivity
perfect.
issue.
Yeah, network. Yeah. So Pandya sir, you know very well that we got the selection in PMT only because of DNA and all. It has to come always that. And this DNA will go, I think, till death. So DNA is the main thing everywhere. So that's important. Yeah.
Doyle is back.
Yeah,
I'm sorry for this bad connection. I don't know what went wrong.
No, it is, madam, just about tech G.
Okay.
It is a tech TACNG, technique of God. That is all genes. TACG.
Welcome back, Doyle. Let us pick up your slides from where you left them.
Yes, that's
Let us pick up the strands of DNA.
I think, let me just.
Your screen has started sharing.
Yeah, I'm trying to share there.
Monica, there are 3-4 Zoom meetings going on simultaneously. You're lucky to have such a good audience here.
I think I'll have to restart the PPT. It has something wrong with the PPT. I'll just quickly restart it.
Okay. Restart it.
It has gone for codon missing, madam.
Yes. Okay. All right.
Yes. Now codon has came. Transcription started.
Okay. All right, so there I was on the process of a transcription. So what happens is during transcription, the T is converted to U. So the ATG is converted to AUG, CCT to CCU, and so on. The next thing is translation. So after transcription, what happens is the messenger RNA comes out from the nuclear pore and it has the transcribed information of the trinucleotide codons. And this transcribed mRNA has to be read by a molecular machinery present in the cytoplasm of a cell, which is the ribosome. And it has to assemble all the individual individual amino acid and make a protein out of it. So this happens by translation. So for this, we need to go through a codon chart. This looks complicated, but actually it is not. On the outer side, you see there are 23 amino acids which are being coded by these 4 letters, A, C, T, and U. So you have to read from the inner to the outer. We are trying to read AUG. When you read from AUG from inner to outer, it translates to a methionine, which is a start codon, which is a signal for starting the translation. And when you keep on reading further, you see that in every individual code results to 1 amino acid. And these amino acids are then joined with each other to form a linear chain. So AUG is methionine, UAA, UAG, and UG are stopped. So what happens is after reading these 3 codons at a time, the ribosome keeps on adding the amino acids and it forms a folded protein. So this is a small bit of what I just discussed. I'll skip it. It just, all you need to remember is The code for transcribing and translating, everything is present within the nucleus, within the DNA. Now from there, you need to then come out with an mRNA strand, and it comes out in the cytoplasm and it assembles a protein. So I will skip through the animation because we are short of time. So, okay, after covering this, I think briefly we just understood that what is the purpose of each of these genes. So the central dogma says that every gene is responsible for creating a polypeptide chain, which eventually forms a protein. So coming to cytogenetics. Cytogenetics is the study of chromosomes. Anything and everything about chromosomes comes into cytogenetics. Now, what is the content of a chromosome? We saw that the chromosome contains DNA, but actually only 40% of a chromosome is DNA, which has a coding and non-coding gene. We will get to it in a while. The rest, 60%, is of packaging proteins like histones and structural proteins. Now, this is the chromosomal state. What do you mean by chromosomal state? The word heterochromatin and euchromatin describe the state in which a chromosome is present within our cell's nucleus. Heterochromatin means closed state, meaning it is closed for transcription. Euchromatin is an open state. When you actually stain a chromosome, the heterochromatin, which is the closed state, wherein it is very compacted, it naturally obstructs light and hence it stains darker. And the euchromatin, which is U meaning good, is the active gene, and it will stain lighter. So briefly, this is a structure of a chromosome. You have a centromere, you have telomere, and short arm and long arm. Let's see a video for it. So the chromosome can be either be represented with a structure on your left, which is chromosome at prophase, or the structure at right, which is chromosome at the metaphase. And here the difference is the structure on the left is a chromosome before replication, and the structure on the right is a chromosome after replication. And both these homologs are called sister chromatids. Now, these chromosomes have, at the center of the chromosome is a centromere. It divides the chromosome into two arms, the P arm and the Q arm. The P arm is the petite arm or the shorter arm, and the Q arm is the longer arm. The purpose of the centromere comes into question when the cell is actually dividing. All the spindle fiber come and attach to the centromere, and they pull both the arms apart. Types of chromosome on basis of shape. On basis of shape, by basis of shape, we mean that by the position of the centromere, we can divide the chromosomes into 4 basic types: metacentric, submetacentric, acrocentric, and telocentric. Metacentric are where the centromere is centrally located, and it kind of divides both the arms into 2 equal halves. Submetacentric is when the centromere is a bit offset and it divides it into 2 unequal arms. Acrocentric is when the centromere is almost at the towards an end, and telocentric is when it is almost at the end. It is such kind of chromosomes are not found in human beings. Now, dividing the chromosome on the basis of the next type of classification of chromosome would be when you divide it by autosomes or sex chromosomes. So we all know, we know it numerous times, that we have 22 autosomes, and we have 22 pairs of these chromosomes, and the 23rd pair is a sex chromosome. These autosomes have 22 in number, 1 from the father and 1 from the mother. And the sex chromosomes is the 23rd pair, which is either X or Y. Now, this is human chromosomes by banding pattern, just like what we saw, that there are 2 kinds of region in the chromosome, making the staining, making some part take a darker stain and some part take a lighter stain. And this kind of a snapshot of human chromosome is called a karyotype. Now, coming quickly to the aneuploidies or structural errors. After seeing the structure of a chromosome and what normally a chromosome is classified as, now we need to concentrate on the errors. 2 kinds of these errors. One is error in number and the error in structure. So numerical error is when you have chromosomal numbers different from 46. The difference could be in two terms. One is when you have more than 2 sets of chromosomes, and the second is when you have mismatch in the total number of chromosomes. So numerical errors when you have greater than 2 sets is called polyploidy. So polyploidy, normally we have diploid cells where you have 2n number of chromosomes. Haploid is our gametes, which has only 1n, and triploid is 3n, and so on and so forth. So when you have more than 2 sets of chromosomes, then the total number of chromosomes becomes 69. When you have tetraploidy, you have 4 times that number, so the total number of chromosomes become 92. Now going to aneuploidy. Now, by aneuploidy, you mean missing or extra chromosome. Here, there is a mismatch in the total number of chromosomes. When you say monosomy, aneuploidy can be of multiple types. 2 of them are monosomy and trisomy. By monosomy, we mean 1 missing chromosome, making the total number 45. And by trisomy, we mean 1 extra chromosome, making the number 47. So monosomy X is the most frequent first trimester loss. This is some of the facts that I have collected from various literature. So like you see here, if you have 1 extra chromosome, then it becomes total 47. Now, tying the information that we had on the central dogma with the kind of chromosomal error, now we need to understand one concept. Genes are present on chromosomes, gene code for proteins. So in a normal scenario, if there are one particular gene on 2 chromosomes are going to produce a normal production of a protein as shown in the diagram. What happens when you have an extra chromosome? When you have an extra chromosome, you have increased protein production because you have duplication of that gene. When you have 1 missing copy of a chromosome, 1 gene no longer is functional. So you have decreased production of protein. Coming to structural rearrangements in chromosomes. Now, structural rearrangements can be either balanced or unbalanced. By unbalanced structural rearrangement, we mean deletion or addition of segments of chromosome. And by balanced, you mean rearrangement of the genetic material. So like we saw, in case of an unbalanced chromosomal structural arrangement, the total amount of genetic information changes because you will either have a deletion or you have an addition. So by deletion, you will have loss of information, and due to addition or duplication, you will have gain of information. In case of a balanced rearrangement of genetic material, you will have total amount of genetic information which will remain constant. It will just be that the information will reside somewhere else than the normal location. If we further divide go into the unbalanced structural rearrangement, we see that we have 4 kinds: deletion, duplication, insertion, and a ring. During deletion, a segment of the chromosome is deleted. During duplication, the segment is duplicated. So naturally, the genetic information is going to be, there will be more genetic output than in a normal case. In insertion, a segment is inserted, and in the ring formation, the chromosome breaks at 2 parts, and these the chromosome then folds and forms a ring. So there will be genetic instability during the time of replication and cell division. Now let us quickly go to the balanced. Okay. When we talk about balanced rearrangement, we have 2 types: inversion and translocation. So in an inversion, there is a break and the entire segment is inverted 180 degrees and then it joins back. So there is no net loss of genetic material here. In translocation, you have 2 kinds. You either have a reciprocal translocation or you have a Robertsonian translocation. In the reciprocal translocation, what happens is there is a transfer of genetic material between non-homologous chromosomes, where the segment of one chromosome is exchanged and it is attached to the other chromosome. And hence there is no loss in the total genetic material. In Robertsonian's translocation, this typically involves acrocentric chromosome. We just saw what an acrocentric chromosome was. So acrocentric chromosomes, when two acrocentric chromosomes, the longer arms of two acrocentric chromosomes will go and fuse together. So that will cause a Robertsonian's translocation. And here there is no loss of genetic material typically. However, due to joining of two chromosomes, the total number of chromosomes in such individual will be less by 1. So hence it will be 45. So Robertsonian's translocation will give rise to both numerical as well as the structural error. So quickly, after covering cytogenetics, let us go to genes and gene mutation. Before we go into gene and gene mutation, two key terms that we all should understand and know by now is cytogenetics and molecular genetics. You must have heard this term while in reference to cytogenetic lab or molecular genetic labs. So cytogenetics is the study of chromosomes, and anything and everything to deal with the diseases and abnormalities in chromosome is studied in cytogenetics. The techniques which are used for studying this is chromosome staining, FISH, array CGH, CGH. And molecular genetics is the study of genes and study of disease due to mutation in genes. And the technique used for this is PCR, molecular cloning, and DNA and RNA sequencing. So if you have to karyotype a patient's blood, then you would typically send it to a cytogenetic center. And if you have to do an embryo biopsy where you want to look into the gene and things at a genetic level, then you would want to send a sample to a molecular genetic lab. Now coming to the gene. Now this is a simplified structure of a gene. In this, we see that there are two parts, exons and introns. Exons are the coding sequences, and introns are the non-coding regions of the gene. By coding sequences or coding gene, we mean genes that are transcribed for further translation. By non-coding sequence, we mean genes that are not transcribed for further translation. So the easy way to remember this is X for extrovert and N for introvert. Extroverts allow interaction, and hence exons allow transcription. Two important concepts, locus and alleles. So the gene's position on a particular homologous chromosome is called the locus. And an allele is a variant or a version of that gene. So we all saw that each cell has two alleles for a single gene, one which is inherited from one parent and the other from the other parent. Now, what do you exactly mean by the version of a gene? So like if you remember the codon chart, we saw that one particular amino acid has multiple ways of being coded. There were certain amino acid which had 3 or 4 different codon combinations which result in the same amino acid. So this is what you mean by the different version of a gene, where even though the end result of the amino acid is same, the code which is coding for it might be a little bit different. So a little bit version of the same gene. When an offspring inherits two similar versions of a gene, then they are called homozygous. And when they inherit two different versions of the same gene, then they are called heterozygous. Now, gene mutation or genetic mutation. So changes in the nucleotide sequence of the gene, typically less than 100 kb, are called gene mutations. Mutations can be either in the protein encoding sequence, which will impact the protein synthesis, or mutations can be in the transcription regulating sequence, which will impact the gene interaction and gene regulation. As a result of disruption of interaction between these molecules, abnormalities will occur in the cell. So if you have to classify genetic mutation into a classification diagram like this, it is actually kind of difficult to classify genetic mutations into such a classification diagram because there are certain overlapping elements, but for simplicity of the lecture, let us go with this classification. Genetic mutations can be classified into either a point mutation or a repeat expansion. We will see what they are. Point mutation can be of two types, either a base substitution or a indel mutation or insertion deletion mutation. Now, point mutation means change in one or two letters of those codons that we were talking about. So we will see with examples, so it will be clearer. The base substitution can be either silent, missense, or nonsense. Now, what do we mean by this? So if you remember the codon, GAA is a codon. And if there is a mutation and the third nucleotide, which is the A, is changed to a G, what happens? Now, GAA codes for glutamic acid. Let us see the codon chart. You will see when you read from the inner to the outer wheel, GAA codes for glutamic acid. So the change of the third letter from A to G did not change much. GAA as well as GAG both code for the same amino acid. So hence, there was not much of a difference. So this is called a silent mutation. Now what happens if the first letter of the codon changes from a G to a U? Again, going back to the codon chart. So a GAA changing to a UAA. When you see UAA, it is a stop codon. So immediately the translation is going to stop and the polypeptide chain is going to stop abruptly. The synthesis of the protein is going to stop abruptly. So this is called a nonsense mutation. There is another possibility where, say, the third letter, instead of A, it is coded as GAA, it is coded as GAC. Let us see what happens then. If we go back to the codon chart, the glutamic acid GAA to a GAC codes for a different amino acid altogether. So GAC is a short code for aspartic acid. So what happens in a missense mutation is that there is a change in the amino acid sequence altogether, resulting in a different kind of protein which is being created. It is always easier to understand something by examples. Let us see a few examples. The example of a point mutation would be Marfan syndrome. Here, tyrosine is actually the change in a the fibrillin gene FBN1 is transformed into a stop codon because of one change in a sequence of that codon. And the resulting fibrillin protein is shorter than normal, and this leads to various kinds of problems. And hence it is called a nonsense mutation. The Marfan syndrome will impact the skeletal and cardiovascular system. The next example is of a sickle cell anemia, which is a missense mutation. So there is only one change in the letter, which is pointed by the arrow. From CTC, the change to CAC causes the resulting amino acid to change from a glutamic acid to a valine. And this results in incorrect amino acid sequence, and this results in an incorrect formation of the red blood cell, which is like a sickle shape, and hence all the problems. Going back to the second type of point mutation, which is an indel mutation or insertion or deletion mutation. Now, indel mutation, depending on how many nucleotide base pairs were inserted or deleted, can be divided into two types: frame shift mutation, or the other doesn't have a name as such, but it is an indel mutation where the mutation is in 3 nucleotide base pair in the multiples of 3 nucleotide base pairs. So let us cover a frame shift mutation. So for understanding a frame shift mutation, we have to first understand what is a reading frame. So frame shift mutations are insertion or deletion in the genome that are not in multiples of 3. They are subsets of indel mutation. So let us first see what is a reading frame. Reading frame is a group of 3 successive base pairs that represent a codon. So the original reading frame is CCU, GAC, UAC, CUA, as you can see on the screen. Now, deletion of just one letter will result in a mutated reading frame. So now the mutated reading frame is going to be CCG, ACU, ACC, and so on. And hence, because of the change in the reading frame, the codon sequence changes, and hence the resulting amino acid sequence chain completely changes. Let us see an example of a frame shift mutation. Beta thalassemia is one of the examples. Here, there are many mutations which actually occur in beta thalassemia, but most of them result in a frame shift. There are about more than 250 mutations which have been identified which lead to beta thalassemia. And this is a normal globin tetramer where there are 2 alpha chains and 2 beta chains. Both of these are coded by separate genes. Beta globin gene is coded by the HBB gene on chromosome 11, and alpha globin gene is coded by the gene on chromosome 16. And when there is a balance between the alpha and beta, then a proper tetramer is formed. In a frame shift mutation, what happens is that there are multiple possibilities with this. One is completely missing beta globin gene. That is not a frame shift mutation, that is completely missing gene. So in that case, there will be not enough beta globin formed. Or there could be point mutations in the beta globin gene, and this would result in shifting of the reading frame, and hence there will be, one of the chromosome is going to code for beta, normal beta globin chains, and the other one is going to code for abnormal ones, and there will be a net disbalance, and it will create a beta thalassemia condition. So now we will go to the next, which is the repeat expansions. Many parts of the human genome have repeated sequences. It is common to have parts of genome with few repeats, like what we see on the screen are CAG repeats. Trinucleotide repeat, or TNR expansion, occurs when the number of triplet present in the mutated gene is greater than the number found on a normal gene. They are also called microsatellite expansions. In a trinucleotide repeat expansion, the number of trinucleotide repeat increases in copy number until they cross a threshold value, which is above the normal gene, and the entire gene becomes unstable. Repeat expansion at times causes a structure called a hairpin structure, which makes the mRNA unstable. Now, repeat expansions can occur either in the coding region or in the non-coding region of the gene. When repeat expansion occurs in the coding region of the gene, we see diseases like Huntington's disease, which is due to CAG repeats, Kennedy disease, which is again due to CAG repeat. When the repeat expansion occurs due to non-coding region repeat, then we see Fragile X, which is due to CCG or CGG repeat, or myotonic dystrophy, which is CTG repeat. Most of these repeat expansions will cause neurodegenerative diseases. Almost coming to the end of the presentation, where now we are trying to classify genetic disorders based on how many genes are involved. If there is only one gene which is involved, then we call it as a monogenic disorder or a Mendelian disorder. If multiple genes are involved, then we call it a polygenic disorder. So single gene disorders are monogenic disorders. There are about 7,000 known disorders which are of single gene type, and they affect over 400 million people worldwide. So this pretty much brings me to the end of it. And these are the references. I'm very thankful to Google for all the references and YouTube. And I'll be happy to take any questions at the end of the session. I hope I stuck to my time.
Yeah, you are very much in time. We are very privileged to have Ms. Bose with us because you have joined the skill of an engineer with the skill of a doctor and the genetics and everything along, and explained us in such a nice manner so that everybody can understand what is gene and how it matters to all of us, how it has changed, and now we can interpret the reports in a much better way. Thank you, Ms. Doyle. Thanks a lot.
Doyle, one day I will keep another 1 hour lecture for you where we can watch all your videos and animations. She never ceases to amaze me, this girl, you know. And with that, she's looking after her lab, her AI, her boss, and her children, 2 little kids. So, Doyle,
definitely combine AI with us.
You are a wonder woman.
Thank you, ma'am.
That's nice, Joel. Lovely to see those pictures. Monica, you're right. We should have another session, a little in depth.
Thank you, Rosa ma'am, for being with us. And I know you have to leave us for another important webinar with Komal. So please, I mean, I'm really thankful for you to chair the session so gracefully for us.
Thank you so much. It was a pleasure, Monica. All the very best to everyone here. Take care. Hope to see you all soon. Bye-bye. Take care.
Bye. Bye. Monica, it was a very nice lecture.
Maybe it was by Doyle.
It was by Doyle, but you selected her to present this thing, the basics of.
I told you, Nadi, this whole year I'm going to just pick up the diamonds from India.
Yeah.
Just pick up, going to pick up, and I'm going to enjoy.
Yeah.
Okay, I think Shabana, let's move.
Then you leave.
Yeah. So we'll move forward and to the third session. Can I get the CV slide of chairperson of third session, Dr. Vishal? So I invite Dr. Chaitanya for chairing third session. He is the chairman and MD Omega Hospital Private Limited, Nagpur, past president Nagpur OB/GYN Society, librarian Maharashtra SR MSR, member Infertility Committee Clinical Research Committee, gold medal MBBS. He has various oration keynotes, faculty in all national and international conferences, published more than 20 articles, editor of Change in MO, GS book, and he also got the MS signature in 2021 and contributed to various books for chapter and various awards in his spread. I welcome Dr. Chaitanya for chairing the session. And the next chairperson is Dr. Shashi Shrivastava. She is Director, Saurabh Nursing Home Hospital, Bhopal, President of Bhopal Menopause Society, Life Member Indian Menopause Society. Our area of interest is recurrent pregnancy loss, sonography, polycystic ovarian syndrome. Welcome, madam, for chairing this session. And I hand over mic to chairperson for introducing our speaker. Thank you.
Thank you so much. And thank you for a wonderful introduction. Good evening, everyone. Thank you, Dr. Sunita Tandwarkar, Monica Randir, for giving us this opportunity. Whenever I get a case related to genetics, I always start thinking I want to grow up once again, because the genetics is such a important topic, but it is really difficult to understand for many. Our friend from Jabalpur, Dr. Dipankar Banerjee, I know Dipankar since last 20-25 years, and I know how sincerely he has been working on the genetics and PGT and in particular IVF in general. Dr. Dipankar Banerjee has done MS from Jabalpur Medical College and is interested in reproductive endocrinology and fetal medicine. That is the science of unborn. He is director of Ideal Fertility IVF and Genetic Center Private Limited, Jabalpur, and is working in the area of interventional sonography, endoscopy, and IVF and prenatal diagnosis since last so many years. He is member of ASTRAE, ASRM, and Ultrasound Society, and also is running academic courses for practicing doctors in fetal medicine and reproductive endocrinology throughout the year. He is also running courses of university students in biotechnology. So for today's very interesting talk on PGT, I call upon Dr. Deepankar Banerjee. Deepankar, over to you.
Thank you, Chaitanya, for this beautiful introduction. And I am with my place where we have our this academic sessions regularly. And after Doyle's, this was a classical music, and the classical music is really very difficult to demystify also. But the thing is, the way she covered the whole genetics, I really admire that she has covered the whole book in within 20-30 minutes. Hats off to her. And
sir, can I
what
take 1
I
minute,
am presenting is will be clinical.
Sir,
And what I am going to say about a case, few days back, I got a call from a pediatrician from medical college. And the baby she was looking after with thalassemia major, beta thal major. And the lady was pregnant again. And she was asking that pediatrician why it is happening, so why it happened, so whether my next baby will be like this or not. So she called me whether we can do anything for that lady, that she can have a healthy baby. This is the basic crux of genetics, that as a clinician, as an obstetrician, we should find out the way how we can give a better option, a better output, and even after output, a better life. So what we do, what I feel that the genetics can be divided into basically a pre-pregnancy genetics. Then there is pre-implantation genetics. Then when she gets a pregnancy, then prenatal genetics. And when this baby delivered, like in pediatric department, that is postnatal genetics. This is the basic thing which we do in our day-to-day practice. Where we can interfere here or here or here, it depends upon this, how you are available with the facilities and how you are approaching the cases. Basic thing what Doyle has covered is that wherever pregnancy happens, because we are talking about basically pre-implantation genetics. That means the lady is not still pregnant. So will this pre-implantation genetics with a healthy embryo? So we should screen a healthy embryo from the available embryo. Whether this couple is having repeated abortion, then we should have, if any chromosomal defect in the parent, then they should get a healthy embryo by selection of the embryo. So this is called pre-implantation genetics of a disease diagnosis. So it is a Mendelian disease. So it is called PGT-M. Whenever there is what Doyle has told, that there might be complications in the chromosome of the parents, so that there is unbalanced chromosomal embryos are happening. So there is a repeated abortion. Whenever there is a repeated abortion because of parental chromosomal defect, these embryo might carry the parental abortion and they might be unbalanced, so they abort. Can we decide an embryo which is balanced so that can have a life? If we do an IVF and then do an embryo selection by looking at the balanced chromosome things, then this pre-implantation genetic test will be for structural rearrangement. So it is called pre-GT-SR. Now, if this patient is having in pediatric department with a baby with beta thalassemia major, and you very well understand in lot of diseases, you cannot treat the baby and you just do a transfusion. With this transfusion, there is a iron overload, and usually if the patient family is not able to support, then baby dies. So what is the treatment? You can have a bone marrow transplant. From bone marrow transplant, you need bone marrow from same antigenic variety of the baby who is alive, that is mostly human leukocytic antigen, HLA, which is common in kidney transplant, any transplant. So in bone marrow transplant, you need an HLA match for the baby who is surviving. Very difficult to arrange. So what the couple can do, because they are fertile, they can make embryos, lot of embryos by IVF. In these embryos, if they match this HLA, so any of the embryos, because it is a sibling of this person, so these HLA will be matched and this embryo is planted and a baby is allowed to deliver. Little bit controversial. You are delivering a baby to help somebody else. When this baby delivers, there is a cord blood stem cell and this baby survives, then there is a bone marrow, and then you can do a bone marrow transplant, then this will become a good bone marrow acceptance. So this PGD, pre-implantation, because we are making embryo not still pregnant and deciding which embryo to be given. This system of pre-implantation genetic testing is called PGT-HLA. Now, where, from which embryo and from where you are going to take the cells of this embryo? Either you take a cell from 8-cell embryo, a cleavage stage, not done nowadays, because you take out the cell, there is more damage to the cell. So what we can do, we can make it grow till day 5, make a blastocyst, and this is the one group of cell, because these cells, they divide and they take a trajectory. One group of cell goes into the periphery just below the shell of the oocyte, that is called zona, and another group of cells which is collected at one place. This is called inner cell mass. Now mind it, these cells are trophoectoderm cells. They make placenta. And these cells, they make inner cell mass, they make baby. It has been seen that if we do a trophoectoderm biopsy, then this embryo survives well. And with the facility of freezing embryos nowadays, you can freeze this embryo and you can go for frozen embryo transfer later on. So 3 things I have given, that is PGT-M, PGT-SR and PGT-HLA. Here the patients are not infertile, they are fertile group. So making embryo is not difficult. Here we are using pre-implantation genetic test for different purpose, a specific purpose, preventing a Mendelian disease, preventing a genetic disease in the progeny, preventing a structural rearrangement and preventing repeated abortions in progeny, or controversially, in some places it is controversial, creating a progeny with HLA matching of a living diseased progeny. Here patients are fertile. Now this thing has been utilized very well in this group. Now, that means we can select the embryo. Now, selection of embryo can be done in IVF also, because it is IVF. So IVF can be done for fertile patient. Here, IVF is done for infertility. Whenever it is done for infertility, we want good embryos. That should implant. How to select a good embryo? First, cleavage stage, because it is not a natural stage to enter into the uterus. So we do a sequential culture. We go for blastocyst transfer. So there is multiple eggs which goes to blastocyst, but few of them they block. So this is called embryonic genome activation, and few of them go to the blastocyst. So which embryo which has crossed this barrier hurdle becomes the blastocyst will be definitely a better potential, because these blastocysts till date 2 or 3, they are thriving on maternal protein or maternal energy or maternal mitochondria. These which have crossed this, they have started creating their own food, own energy. So there is a hurdle race. Who wins the race will be the winner. So this is a one method. Now there is a blastocyst grading. Which blastocyst is better? So there is a morphology. Now with morphology, either I should see subjective or I should see with machine. That is by time lapse. Ultimately, this time lapse also see the morphology. So if you have a good morphological and subjective eye, you can match with time lapse, because time lapse can give a selection of good blastocyst, but pregnancy rate with a good grading with Gardner's grading are equal almost. But definitely it helps to select a good morphology. Even this morphology embryo, they do not implant. Then what happened to this? Then how to select this embryo again? Now this embryo selection is done by, because we have done these things, so we can apply this technique here also. We cannot touch inner cell mass because embryo will die. So what we can do? We can do a biopsy from here. If we do biopsy from here, so any cell which is, we call it 2N and 2C, that is 2 copy of chromosome, each from one parent, that is 46 chromosome in a cell, is called euploid. Any 2N plus 1 or 2N minus 1 is not euploid, so it is aneuploid. And if N is 3N, then it is polyploid. This is the basic thing. And because of this, this might not implant. So for selection of the embryo, we can do a tropoectoderm biopsy and do a analysis of these cells, whether they are 46 or not. So there is a first fish method, because we want to see whether there is a Down syndrome or not. So 5 chromosome were taken. But with this 5 chromosome, what about other chromosome? We came with the 24 chromosome. How to see 24 chromosome? Take the DNA of these cells and then do DNA analysis. I am not going into those details because it will become boring, because for a clinical purpose, this is enough to know whether we can see 24 chromosome in which way, either comparative genomic hybridization or array CGHS. Most commonly nowadays is NGS. NGS is a very detailed visibility or seeing the chromosome or DNA inside. Each packet is seen very detailed. So what happens? You can see a lot of those details which are not there in product of conception. So these reports sometimes give you a aneuploid or complex aneuploid or unbalanced, these things will create a rejection of the embryo, and patient might not have a good embryo even though there is a good morphology. Now, if this is rejected, does this report of tropoectoderm is actually the report of baby, that is inner cell mass? In prenatal tests, we do a test called NIPT. NIPT is a prenatal test. It is a pre-implantation genetic test. In NIPT, the cells which are coming or DNA which is coming from are from trophoblast or placenta. If something abnormal is here, we always do an invasive test and see the baby. That is called amniocentesis. If it is still there, then we take a decision. But in PGT for aneuploidy, we see the placenta and reject them. So this is some controversial thing which are there, and I'm finishing my talk with these are the techniques and from where I took this information, and lot of book. These are the various literature and books which are on prenatal genetics. And the thing is, very important thing came in focus on reproduction from Eshrey, that cumulative live birth rate in PGT-A falls below that of routine IVF in new SART analysis. This is very recent, 30th Jan 2023. So a lot of controversies are going on. There are a school of thoughts that everyone should do PGT-A for all IVF cycles. Another school of thought which says that we have gone to a dead end for pre-implantation genetic testing for aneuploidy. Are we selecting those embryos which we do not know whether the inner cell mass is same? Now there is a word called mosaic. So it is a gray zone. It is neither total aneuploid, total euploid. So how can I decide? They have decided these. We take out the DNA. I'm finishing this talk because it will become very long. I don't want to make it long, but more clinical. When we do this trophoectoderm biopsy, what you are seeing here, we take few cells from here, and each cell is having DNA. Now, if each cell is having DNA, then we can get a DNA mixture. This DNA mixture will have to make photocopy, multiple copies. During copying, there might be some problem. So there should be a good copy machine. So that is called whole genome amplification by various techniques, not going in detail. When you get large number of DNA by genome amplification, then you do sequencing of all these pieces. Then compare with the normal pieces. If they compare with the normal pieces equal, then it is 100% euploid. If it is 100% non-equal, then 100% aneuploid. Now, something equal, something not equal, mosaic, different shade. How much mosaic accepted? Somebody says 20% mosaic accepted. Somebody says 30% mosaic accepted. Even sometimes they say 50% accepted. So we are in an era where if we are giving a service to a lady who is already 35, 40 with very low AMH, only making one good quality embryo, good quality blastocyst, it is very difficult to decide whether we should do it PGT aneuploidy, because lot of things comes even by the type of biopsy, by the way of biopsy, by using the laser, creating a cell damage, creating a chromosomal damage, which gives the lab report as a complex aneuploidy. I see a lot of reports with complex aneuploidy, which I never saw in product of conception, which is aborted. And if you see 50% of the blastocyst, if you analyze in this way, 50% will be aneuploid. But if these mosaic embryos are implanted and they get a pregnancy, again, they say always do an invasive test. Now, if I do an invasive test at 16 weeks, only after 40 years, only 1 to 2% are aneuploid. So where it is 50% aneuploidy pre-implantation, it becomes 1 to 2%. That means there is some selection or there is some spontaneous correction in the baby, which happens. So be careful about the, and this is the Pre-Implantation Genetic Information Society positional statement transfer of mosaic embryo in 2021. Very confusing. And the thing is, if don't have embryo of full euploid, have mosaic, then transfer that mosaic. Again, there is a caveat that inform the couple that we are doing this. So everything goes on the couple that they should take this responsibility. So shouldn't we take responsibility what we are doing? So there should be a balance between giving the test, counseling them, and what will be the post-test counseling. And should we do this test for those patients making 1 or 2 blastocysts in their later part of the life with low AMH? It is a personal call which you can do. You can have your own assessment and take a decision according to your wisdom. Thank you very much for patient listening.
Dr. Deepankar, you have done a wonderful job.
Wonderful.
A difficult subject in a very simpler way. What is PGT and how should be it is helpful to routine our gynecologists to use it in a very simpler way. Thank you, Dr. Deepankar. You have done a great job. Thank you.
And Deepankar sir, you have opened such a big box of science is now like a double-edged sword, whether to go forward or go back. So again, we go to our program coordinators to take us ahead, because next talk is going to be again a mind-blowing talk. So request to everyone to not go away. Stay with us.
So thank you so much, Deepankar sir. And now moving forward to our fourth session, that is a talk on ultrasound and genetics. I'm inviting Dr. Rajul Tyagi to chair the session. She is President Association of Private Gynecologists of Lucknow, Vice President SPAT Managing Committee 23-25, Vice President SPAT UP Chapter, Vice Chairman SR UP Chapter, Past Secretary SR UP Chapter, and Director of Javitri Hospital and Test Tube Baby Center, Lucknow. She is a member of various organizing committee, and she is a master trainer for various international fertility training programs of IVF, ICSI, embryology, clinical infertility, and to her credit lots of many awards like Nari Award, Istri Shakti Puruskar Award, and Nari Award and Women Achiever Award. So I welcome Rajul Madam. And next chairperson is Dr. Priyankur Roy, and he is Assistant Professor Lord Buddha Koshi Medical College, Saharsa, Consultant Infertility Gynec Endoscopy Roy's Clinic, Ramakrishna IVF Center. He is Chairperson Public Awareness Forum FOXY, Vice President FICO, Member Contraception Committee, and he is an invited faculty in many international and national conferences, including FIGO, and publication is more than 75 articles in national and international, and lots of many awards to his credit, like FOXY Corion Award, FOXY Future Award, Dr. Kamini Rao Orator Award, and Dr. Shanti Yadav Award in Infertility. So I welcome Dr. Priyankur Roy to chair the session, and I hand over mic to the respected chairperson for further proceedings. Thank you.
Thank you so much, ma'am, for the kind introduction. I would really like to thank Randeep Singh sir and Monica ma'am for giving me this opportunity to be part of this wonderful webinar series, Genetics in Practice. And there has been such wonderful talks, the previous 3 talks, and we learned so much about genetics because I personally have to be a little honest that genetics is something that maybe do not take too much of interest into, because if there's anything that comes up, refer to someone who is an expert in genetics, because it's a lot of, lot of thinking and a lot of things that go into it. So I have learned a lot personally on this from this first 3 talks, and I'm sure I'm going to learn a lot from Dr. Divya Singh's talk as well. So ma'am she is a senior resident. She has done a fellow in advanced gynae endoscopy, gynec ultrasound from Mediscan in Chennai. She is currently a consultant radiologist at the Prime Imaging and Prenatal Diagnostic in Chandigarh. She is an expert in the subject and is a member of ISUOG task force as well as basic training and outreach working group. She has received a number of awards, including an award by the Ministry of Health from Chandigarh, and also has a best paper in ultrasound in endometriosis in Sonoscon 2020. I'm also happy to see that she has also published a lot of papers to the tune of 52, and I'm sure it's going to be an ever increasing number. So Dr. Divya is going to talk to us on a very interesting topic, ultrasound and genetics, a happy couple, to see whether they go hand in hand, whether they complement each other, or will it be a case where ultrasound is better, genetics is not as good or something. But I think Dr. Divya will throw a light where she'll tell us that both of them are good and both of them needs to be together for a better diagnosis and for better patient management. So over to you, Dr. Divya, for your talk, please. Rajul ma'am, happy to see you also. Ma'am, if you want to comment anything before we move on, or should we go on with the talk, ma'am?
मैडम आप अनम्यूट है मैडम. राजुल मैम अनम्यूट करिएगा.
मैडम प्लीज अनम्यूट.
राजुल मैम माइक को अनम्यूट करिए. राजुल मैम वी आर नॉट एबल टू हियर यू. आप माइक को. हाँ,
I think we move ahead with the talk.
Yes, we'll move on. Until then, I'm sure Niharika will get things right for Rajul.
Yeah. Niharika will help her.
Welcome, Dr. Divya.
Welcome, ma'am. Please go on.
Good evening, everyone. I would like to thank Dr. Priyankur for the kind introduction. And before I begin my presentation, I would like to extend my heartiest congratulations to Dr. Monica for having organized this academic extravaganza. It has been a pleasure to listen to all the stalwarts who have presented their perspective and experience with genetics so far. It has been a very enlightening session as far as I am concerned. It is my privilege to be a part of this esteemed forum, and I thank ISAR for this opportunity. In the next 20 minutes or so, I will speak on how ultrasound and genetics complement each other and help us in our daily practice. The learning objectives of this presentation would be to highlight the difference between the screening and diagnostic prenatal tests that we use in our day-to-day practice. We would need to understand that each prenatal genetic test serves a specific purpose, and hence it has to be used judiciously, keeping in mind what we intend to achieve with it. Both ultrasound and genetic testing are complementary. One cannot do without the other. And it's important that before we go in for testing, we have a detailed assessment of the index case or the case in point. This assessment may not only include antenatal examination by ultrasound, but at times it may need to be supplemented by postnatal evaluation in the form of a detailed clinical examination, radiographs, and if the pregnancy has any unfavorable outcome, fetal autopsy. These are terms which you would often hear in genetic presentations: phenotype and genotype. So phenotype is the external appearance of an index case, and genotype is its genetic makeup. We must always remember that phenotype predicts genotype. So how an individual or a case appears determines what its genetic makeup would be. And that is how genetic testing is guided. Our role as fetal medicine specialists or imaging specialists is to elucidate or describe the phenotype in great detail so that targeted genetic testing can be performed, as you would see in the subsequent cases. Now, these are all common cases which I have seen in my clinical practice, and we begin with case 1. which is that of Mrs. A, a 38 years old lady who had a non-consanguineous marriage. She came to us in her second pregnancy. This pregnancy had been conceived by IVF with the lady's own egg. She had a previous live issue, which had been delivered normally, a 7-year-old girl who was alive and healthy. Her medical history was insignificant except for the fact that she was chronic hypertensive and was on medication for the same. Now, as is the practice, between 11 to 14 weeks, at 12 weeks, she'd undergone her nuchal translucency scan combined with first trimester screening for aneuploidy. At that point of time, this was the CRL, that is 52 millimeters with a normal nuchal translucency thickness. Nasal bone was seen. And if you would see her biochemical report, what we often allude to as dual marker, this was beta HCG. It was 0.5 multiple of median, PAPE 0.3 multiple of median. Now, please remember, ideally, these should be 1 multiple of median, that is 1 mom in normal pregnancies. So the moment the level of these biomarkers, which are actually derived from the placenta, is above or below 1 mom, then the risk for various aneuploidies as well as for certain other conditions changes. So as a result of, though her NT scan was perfectly all right, because of this change in the biochemical markers, her final risk for trisomy 21 was 1:339, which we all understand is intermediate risk because it falls between 1:250 and 1:1000. Whereas the risk for trisomy 13 and 18 was less than 1 in 50, so it was high risk. So because of these biomarkers, there was a risk for both trisomy 21 as well as trisomy 13 and 18 in her combined first trimester screening. She was offered the option of non-invasive prenatal screening, which she opted for. And this was also performed by the same lab who had done the biochemical screening. And in the NIPS result, as you can see, it was low risk for all the 3 trisomies as well as for sex chromosome abnormalities with a fetal fraction of 8%. So ideally, in singleton pregnancies, the fetal fraction should at least be 4% for an NIPT report to be optimal. Now, we saw her for her anomaly scan at 19 weeks, and this is her background history. So when I performed her anomaly scan, the first thing which I observed was that all the fetal parameters were less than 5th centile. Now, this was a pregnancy which had been conceived by IVF, so there was no doubt about dating of the pregnancy. And of course, her first trimester scan had also been corresponding to the expected period of gestation. So here was a case of early onset fetal growth restriction at 19 weeks. The amniotic fluid was normal. The uterine artery Doppler was normal. However, what was interesting was in fetal anatomy, as you see here. Now, these are the scan findings, which I will just label for you. And this is the axial section of the head. This is what a normal choroid plexus looks like. And in the other choroid plexus, what was seen was this anechoic oval lesion, which is a choroid plexus cyst. Now, if this was seen in isolation, it probably wouldn't have been of much significance. But here was a baby who was growing small. There was a unilateral choroid plexus cyst. That wasn't enough. If you look at the skull, it had a very peculiar shape, what we call as the strawberry-shaped skull. And if you're not convinced that this looks like a strawberry, well, I'll just show you an animation, and you can compare that it indeed looks like a strawberry with a flattening of this occiput. The heart was also a little off. We could just see 1 cardiac chamber instead of 2. So there was a cardiac anomaly as well. The face was fine. We could see the nasal bone. And what was interesting was that despite prolonged repeated examination, the baby kept its hand in this peculiar position, which we call as the pointing index finger. So it had 3 fingers clenched with the index finger pointing, and this persisted despite repeating the scan over a period of 2 to 3 hours. So we saw the patient intermittently, but it refused to open the hands. So all these findings, when we take in toto, are suggestive of a common aneuploidy, and this is what it was. So as you can see, this is the summary of the findings, and this characteristic early fetal growth restriction with a choroid plexus cyst, strawberry-shaped skull, a cardiac anomaly, and the peculiar pointing index finger suggests a aneuploidy, that is trisomy 18, also known as the Edwards syndrome. Now, in view of all these findings, the couple opted for termination of this pregnancy. However, for confirmation, the abortus was sent for karyotype. As we all understand by now by Doel's presentation, trisomy 18 is just a numerical chromosomal abnormality in which instead of 2 copies of chromosome 18, we have 3. And this can easily be picked up by a simple, reliable test, that is karyotype. As you can see, this is how a karyotype report looks like. Normally, you should see 2 sets of chromosomes, one from the mom, the other from the dad. But in this case, in the abortus, we could see 3 sets of chromosomes at the location of chromosome 18. And this is how a karyotype of chromosome trisomy 18 or Edwards syndrome looks like. So as you can see, despite the fact that non-invasive prenatal screening was low risk for trisomy 18, ultrasound picked up certain non-reassuring findings which were suggestive of trisomy 18, and the eventual result also helped in confirming what ultrasound suspected. Now, what I want to drive home by this case is the difference between screening and diagnostic prenatal tests. We must understand that screening tests like combined first trimester screening, non-invasive prenatal screening, quadruple test are relatively rapid, simple, some of them cost-effective tests, which are applied to a healthy population. And what they give, the information or the result that they give is classifying that those healthy individuals into low risk or high risk. That is, we get a likelihood for the presence or absence of the disease. It's not like a yes or no answer, but a ratio. Whereas when we go for diagnostic tests for which we obtain the sample prenatally by invasive methods, be it chorionic villus sampling or amniocentesis or cord blood sampling, these diagnostic tests are usually targeted at individuals who are supposed to be affected or diseased in a particular way. And these tests have much higher accuracy as compared to screening tests. However, in case of prenatal setting, they do have a small risk of complications, which we are all aware of. But since they provide definite answers, yes or no, these diagnostic tests help in early and proper management of pregnancies. So whenever screening tests are off, we cannot jump to a conclusion based on screening tests. We have to perform diagnostic tests to confirm what has been suggested by screening tests. And ultrasound works along with screening tests and diagnostic tests so as to understand whether the information that we are getting by a screening or a diagnostic test is corroborating with the ultrasound findings or not. Now, I'll just talk in brief about the 2 common screening tests which we saw here, that is the NIPS and the first trimester combined screening. As we all know, NIPS has been touted to have a very high detection rate for trisomy 21. In fact, if the question is, if you just want to screen for trisomy 21 in an individual, then the best test is NIPS. But that is not the case if you look at other trisomies and sex chromosome abnormalities. So if you want an answer whether, if you want to screen only for trisomy 21, then it's a good idea to offer NIPS because it has a very high detection rate. And first trimester screening, however, has got a relatively lower detection rate. But there are these biomarkers like PAPE, which are used in first trimester, that is combined first trimester screening, also give an information for certain other maternal complications like preeclampsia. So if we see a low PAPE mom that is less than 0.4 MOM, despite the other things being normal in a first trimester screening result, it makes us think in terms of early onset preeclampsia. So that is the advantage of biochemical screening over NIPS. Now, why did NIPS not detect trisomy 18 in the previous case? This is because the detection rate of NIPS for trisomy 18 is different from that of trisomy 21. Now, various studies have shown and labs claim that detection rate for trisomy 21 is as high as 99%. But studies for trisomy 18 have showed that the detection rate by NIPS for trisomy 18 can vary from as low as 59% to as high as 99%. So for other trisomies than trisomy 21, NIPS is not that sensitive. And that is probably one explanation as to why the NIPS could not pick up trisomy 18 in the previous case. Another thing which we fail to look at whenever we are talking of screening tests is this concept of positive predictive value. Now, positive predictive value means that if a test comes out to be positive, what is the chance that a baby is likely to be affected by that condition? For instance, NIPS, especially in older women above 35 years, is said to have a positive predictive value of 80% by certain companies. So what it means is that if there is a positive NIPS result for trisomy 21, there is only an 80% chance that the baby is likely to have trisomy 21. And that is why it's very important, because as Sir pointed out, what we test in NIPS is not the fetal DNA, but actually DNA from the placenta. And that is why whenever an NIPS shows a high risk for trisomy, it needs to be confirmed by a definite test of the fetal sample, and the fetal sample can be obtained only by amniocentesis, because what we test in amniocentesis are the fetal skin cells. So if there is a positive screening result, we cannot take any decision regarding continuation or rather termination of a pregnancy just based on a screening test. We must confirm it by a diagnostic test. And as you can see here, the positive predictive value for trisomy 18 by NIPT is even more dismal. So if an NIPT says that there is a high risk for trisomy 18, there is only a 50% chance that it will be correct. And there's a 50% chance that the fetus may be absolutely normal. So if you have a positive test for NIPT with trisomy 18 and the ultrasound is normal, then there is a strong chance that the NIPT may actually be wrong, because trisomy 18 and 13, these are two aneuploidies which usually in more than 90% cases are accompanied with ultrasound abnormalities, unlike trisomy 21, in which case the ultrasound may be normal and the baby may still be affected. Now, I've dwelled a lot about on these screening tests, but what I just want to highlight is that screening tests are like sieves. So depending on what type of screening test you use, whether using combined first trimester screening or NIPS to screen for Down syndrome, you will have a number of false positive and false negative results, which you must be aware of. With this, I move to case 2. Now, case 2 was that of Mrs. B, a 31-year-old lady with a non-consanguineous marriage. She had conceived spontaneously, and again, we saw her in her second pregnancy. Her first issue was a 4-year-old boy delivered normally. He was alive and healthy. She did not have any significant medical history. Combined first trimester screening and NT scan had not been done. This patient actually came to us during COVID times when patients had limited access to hospitals and preferred to stay at home. So quadruple screening had been done, which was low risk for common aneuploidy. The biometry was appropriate for gestation, so the baby was growing fine. The amniotic fluid was normal. And again, ultrasound showed certain unusual findings at 22 weeks. As you can see, this is an axial section of the chest at the level of the left ventricular outflow tract view. So this is just an image of the heart basically. And what we can appreciate here is a ventricular septal defect. So there was a ventricular septal defect. This is a section upper in the chest where we look at the 4 chambers at one level, and then there is a section where we look at the outflow tracts of the heart. So this is a section for the outflow tracts. Normally at this level, we see 3 blood vessels, namely the pulmonary artery, aorta, and the SVC. However, in this baby, we could only see 2 vessels, 1 large artery and the superior vena cava. Now, just to highlight, this is what this view normally looks like, 3 vessels here. But in our case, there were just 2 vessels, 1 big artery and a vein. So obviously there was some cardiac anomaly. Another interesting thing, especially if there are fetal medicine specialists here, was a small thymus. Now, how do I say that the thymus is small? First, we need to understand what the normal thymus looks like. Now, this is a normal image of the thymus. Thymus is a hypoechoic structure, which is seen in this view anterior to the great vessels, that is anterior to pulmonary artery and aorta. And normally, the thymus should occupy at least 50% of the distance between the anterior part of the spine and the sternum. So this is the thymus just behind the sternum in a normal baby, whereas you can appreciate there's hardly any thymic tissue between the sternum and the great vessel. So here was a small thymus. So we had a baby with a cardiac anomaly, a small thymus. And again, for fetal medicine specialists, this is what we call as a cavum septum pellucidum. And if you note, this cavum septum pellucidum had a large amount of fluid. It was almost as much as that seen in the lateral ventricle. So this was a wide cavum septum pellucidum. And there has been a publication recently in literature which has linked this finding along with what we call as DiGeorge syndrome or 22q11 microdeletion. If trisomy 21 is the most common trisomy or aneuploidy, then the most common microdeletion syndrome is 22q11 or DiGeorge syndrome. And based on all these findings, we could suggest based on ultrasound that this baby could be having 22q11 microdeletion or DiGeorge syndrome. Now, it was a pregnancy at 22 weeks. They wanted to confirm whether the fetus was affected or not. And so amniocentesis was done. So we got the fetal sample, the fetal skin cells. Now, what test do? We did karyotype when we were suspecting trisomy 18, but would that work here? Well, as Ms. Doyle pointed out, this is what the DNA structure looks like, and this is what karyotype does. It stains the maternal and paternal chromosomes for us, and it can detect either additional material or deleted material in the chromosomes, but of a particular size. For instance, there has to be a gain or loss of at least 7 million base pairs or more for it to be evident on a standard karyotype. Because remember, chromosomes are seen under a microscope in case of karyotype, and there has to be a significant loss for that to be appreciated under that microscope. On the other hand, we are suspecting what we call as microdeletion. So the word microdeletion implies that a very small segment of the chromosome has got deleted. Now, usually in 22q11 microdeletion, this is to the tune of 1.5 to 3 million base pairs. So actually half or even less than what a karyotype can detect. So if I were to do a karyotype in this case, I would get a normal report and not be able to come to a conclusion. But now, since the ultrasound is highly suggestive of a microdeletion syndrome, and in the presence of a structural anomaly, it is recommended to perform microarray as the first step, because it not only detects certain things which are detected by karyotype like trisomy 13, 18, that is aneuploidies, but it can also detect microdeletions and microduplications. So when we have a fetus with structural anomaly, the first line of testing is microarray. And why? Because it can detect even smaller deletions and duplications. That was performed. So amniocentesis was performed and the sample was sent for microarray, and this 22q11 microdeletion was confirmed, after which the family opted for termination of pregnancy. Now, just to draw an analogy here to remember, now, if you consider a library or a book with shelves, what karyotype does is it can identify a missing book or an additional book in that shelf. However, what microarray does is that if there is a missing page in a book, that is what microarray can pick up. So if you want to look for a missing book, then you would do a karyotype. But if you want to go into greater detail and look for microdeletions, microduplications, or a missing page in a book, you would do a microarray. Coming to case 3, and this would be my last case, but this is something that we see in our day-to-day practice, day in and day out. This was Mrs. C, a 28-year-old lady, again with a non-consanguineous marriage, spontaneous conception. She was a primi gravida with no significant medical history. This is what we saw in her NT scan at 12 weeks, 3 days at a CRL of 60. Nuchal translucency was thickened, even if you don't measure it. Even by eyeballing in this axial image of the neck, you can appreciate this extensive nuchal thickening, and it measured 3.8 mm in the mid-sagittal plane. If you're more familiar with the anatomy of the mid-sagittal section, you can see that the nasal bone was ossified, so we could see the nasal bone. However, once the nuchal translucency is thickened, any discussion about screening tests goes out of the window, because please remember, screening tests are for healthy individuals. And nuchal translucency, a thickened nuchal translucency, is a very strong marker, not only for trisomy 21, for many other chromosomal abnormalities, even for single gene disorders. In skeletal dysplasias, especially of the lethal type, there can be thickened nuchal translucency in the first trimester, and even cardiac abnormalities can be associated with a thickened nuchal translucency. So the moment we see a nuchal translucency which is thick, there is a lot of work to be done. Screening tests are totally discarded, be it first trimester biochemical screening or even NIPS, and we need to do more. We need to evaluate the fetal anatomy in detail, which would be done by an ultrasound by a specialist. And of course, we would offer diagnostic testing straight away to the patient. The guidelines for defining nuchal translucency is different in the UK. They use a cutoff of 3.5 mm or more, whereas ACOG, the American guidelines, say that a nuchal translucency of 3 mm or more warrants direct diagnostic testing. Now, how would we manage a fetus with a nuchal translucency of 3 millimeters or more? Now, when we see this at 11 to 14 weeks, we would of course perform a detailed ultrasound to rule out other structural anomalies. Also, we would need to rule out, the first step would be to rule out chromosomal abnormalities. The chromosomal abnormalities, if we are to rule them out at 11 to 14 weeks, the test that we can do is chorionic villus sampling, that is taking sample from the fetal placenta and sending it. Remember, NT is a marker for a lot of abnormalities, so you won't do a karyotype. You would be doing a more detailed test, that is microarray, as well as storing the DNA. And this is important because, just chromosomal abnormalities are not the only cause of thickened nuchal translucency. There can be what we call as single gene disorders, and those mutations would not be picked up by a microarray. So it's a good idea to store the DNA in case we come up with a surprise later on in pregnancy. We would call, if the ultrasonography is normal, microarrays report is fine, we would not let the patient go just like that. The fetus would again be seen at 16 weeks. So we would do an early anomaly scan at this point of time, which would include a detailed evaluation of the fetal heart. Because as I stressed, there can be thickened nuchal translucency associated only with a cardiac abnormality. So again, at 16 weeks, we would try to rule out major structural abnormalities using ultrasound. If they are not there, well and good. We would also look at the nuchal fold thickness, because at 16 weeks, we cannot measure the nuchal translucency. We would measure the nuchal fold thickness. And at this point of time, the cutoff for NFT is 6 millimeters. So if it is less than 6 millimeters, it is reassuring. If it's more than 6 millimeters, it is still thick. So if the nuchal fold thickness is now at 16 weeks, less than 6 mm, we do not see any other abnormalities, and we have a normal microarray report, we can reassure the couple, but still not let them go, because remember, fetal development is an ongoing, evolving process. You can again come up with surprises later on. So we would again assess the fetus by ultrasound at 20 weeks. However, if the nuchal fold thickness doesn't resolve and we don't see any major structural abnormalities, we cannot sit at rest. We have to try and find out if there can be some other cause of this thickened nuchal fold, and which could be in the form of screening for infections or doing further genetic testing. Now let us see what happened in the case which I discussed just now. So as I said, the fetus had an NT of 3.8 mm. However, when we performed a detailed ultrasound at 12 weeks, 3 days, the anatomy was perfectly fine. Cardiac evaluation was also done. That was normal. So the patient underwent chorionic villus sampling at 13 weeks. Microarray with DNA store was done. Microarray report was normal. So now we've excluded major chromosomal abnormalities, microdeletions, microduplications. We saw her again at 16 weeks, did a detailed ultrasound along with cardiac evaluation. There were no major abnormalities. nuchal fold thickness was less than 6 millimeters, was normal. That was reassuring. That is why the patient was seen again at 19 weeks. Again, ultrasound with fetal echocardiography was performed. Everything was fine. The patient was reassured, and this pregnancy was followed up, and this baby ended up having a normal outcome. So the baby is today around 2 years old and is doing fine. So remember, a thickened nuchal translucency should not make you take hasty decisions like termination of pregnancy. Rather, it is the thing which should prompt you to evaluate the fetus in detail and see how things evolve. Now, this is another case of thickened nuchal translucency. In this case, as you can see, the nuchal translucency was 3.5 millimeters. This case was referred to us. The anatomy had been assessed at the NT scan and was reported to be normal. Since she came to us when she was already around 16 weeks, amniocentesis was performed because CVS cannot be done at this point of time. DNA, of course, was stored. However, at the time of amniocentesis, it was noted that the nuchal fold was still thick. It was around 6.7 millimeters. So the microarray report, as you know, it takes around 2 to 3 weeks for the report to come. So by the time the report came, she was around 18 plus weeks. However, the microarray report was normal. So she was kind of reassured with herself when she came to me for her anomaly scan at around 19 weeks. But this is what we saw at 19 weeks. There was marked increase in thickness of the nuchal fold, as you can appreciate. This is the thickened nuchal fold, and you don't even need to measure it. Even on eyeballing, you can see that it is way beyond 6 millimeters. There was also accompanying prenasal edema. So the skin edema had actually increased at 19 weeks, despite the patient having a normal microarray report. So what does this mean? It doesn't mean that the report is not correct. It just means that there is something else, some other kind of genetic issue, and we need to test in more great detail. And that is why the next important cause of a persistently thickened nuchal fold is what we call as rhasopathies. Now, these are conditions which are at a gene level, and so they cannot be picked up by standard microarray. For these, the test that we perform is what is called as clinical exome. Remember, we spoke about exons and introns. So clinical exome looks for the coding part of the DNA, that is the exons. And so a clinical exome was performed and a diagnosis of Noonan syndrome, which is a single gene disorder. It cannot be picked up by karyotype. It cannot be picked up by microarray. It can only be picked up by next generation sequencing techniques. That is what was made in this case. So if I said that microarray is like looking at missing pages or added pages in a book, what is exome sequencing like? It is like looking for missing words in a sentence. So if you have a sentence and you want to pick up missing words in it, that is when you would go in for clinical exome. So genetic testing has to be done in a graded manner, depending on what you see on ultrasound. So that is how ultrasound and genetics work together to complement each other. And finally, the last case. Again, this was a case of a thickened nuchal translucency more than 3 millimeters, 3.2 mm. And if you look at the face here, the nasal bone was also unossified. So the nasal bone wasn't seen. Now, remember, whenever you see a thickened nuchal translucency, it's not just genetic testing, it's also structural evaluation. And when we assessed the fetal heart at 12 weeks, we could only appreciate one cardiac inflow and one cardiac outflow. Now, just for comparison, the normal first trimester heart looks like this. So these are the two cardiac chambers, the left and the right. And these are the two normal outflow tracts, the ductal arch and the aortic arch, which form a kind of V. And you can appreciate we cannot see one of the inflows and one of the outflows in this case. So this was a baby with hypoplastic left heart syndrome. The same was conveyed to the patient. This was her second pregnancy. She had a previous alive, healthy child who was 3 years old. However, in view of unossified nasal bone, thickened nuchal translucency, she was worried about a chromosomal element to this condition. Though we know from our background knowledge of genetics that hypoplastic left heart syndrome has a very low chance of being associated with genetic disorders, but still, because of the unossified nasal bone, she was offered the option of diagnostic testing for chromosomal abnormalities, which she opted for. So a CVS was performed and the sample was sent for microarray. The report was normal. So no pathogenic copy number variant was detected. So it's just that ultrasound can sometimes also help in predicting the negative predictive value of a test. So even though we knew that the chance that this test would come out to be positive for a chromosomal abnormality was low, since the patient wished to confirm, this was offered to her. So this is how ultrasound and genetics work together. Ultrasound is sometimes guided by genetic tests and vice versa. And that is why it's important to have a multidisciplinary team and work together in order to come to a meaningful conclusion and give the best possible outcomes to our patients. I hope at the end of this presentation, I've been able to highlight the difference between screening and diagnostic tests, the complementary role of ultrasound and genetic testing, and why appearances matter. That is why we always have to improve our ultrasonography skills to keep pace with the evolution in the field of genetics. And in case you're interested, I would invite you to read our latest publication in which we were able to, again, with the help of ultrasonography and genetics working in collaboration, able to pick up a condition which has been reported in less than 100 individuals in the world. And we could pick up a new mutation which has not been reported so far. Thank you so much for a patient hearing.
Do we have the chairpersons?
Monica ma'am, you're on mute.
Oh. Yeah.
Yeah, thank you, Divya ma'am, for the wonderful talk. It was really an eye-opener, I would say, because we got very excellent inputs and excellent insights into the subject, I would say. So we have, of course, our experts. Monica ma'am is there with us, Randeep sir is there with us, and I think they will give us more expert comments on this. And if Rajul ma'am is also there with us, I think we'll take a couple of comments from her as well.
I think we have got Preeti Tomar with us, who is herself is a fetal medicine specialist from Indore, and we have Niharika Tyagi, who is, I think, who has done specialization in this after her MS. And what I can see is, Divya, you're just amazing. And you gave us a lot of food for thought that at increased NT, don't get hassled. But my question is, don't get hassled when there's increased NT, but what if there's an unossified nasal bone? Can that also lead to a normal outcome?
Yes, ma'am. As you can see, in the case where we had this hypoplastic left heart syndrome, there was accompanying unossified nasal bone. But when we did microarray, it was normal. So actually finding an unossified nasal bone alone in the first trimester, it doesn't necessarily equate to Down syndrome again. It again warrants correlating what we see with the aneuploidy screening results. And based on how high or low the risk for trisomy 21 comes out to be, we offer genetic testing. In fact, I would share from our personal experience that when we do diagnostic testing like amniocentesis, for an isolated, the bottom line is it should be isolated unossified nasal bone in the second trimester, especially if the biochemical risk and the combined first trimester screening risk has been low. More often than not, we get a normal result. So unossified nasal bone in isolation actually has a good outcome, and the children are chromosomally fine.
And I must confess that Dr. Divya teaches us so many things, so many cases she keeps discussing, and I'm her most irregular student. I just pop up in between and then I'm missing for days. So Dr. Divya, it was an amazing talk, and I think Preeti Tomar will give us more inputs when we go to the panel. Thank you so much, Dr. Divya.
Yeah, Dr. Divya, you people, young people are coming so nicely. So मुझे तो बीच में नींद आ रही थी, but your talk was so it was very, very amazing. Good talk.
Thank you, sir. Thank you very much, sir. Thank you for the kind invitation, sir.
It was a pleasure having you.
Yeah. So Dr. Shavana will go to next.
Thank you.
Yes,
Thank you so much once again.
To the very interesting part. Last but not the least, a very interesting part of our webinar, that is panel discussion, genetics in action, clinical case studies, pre-implantation and prenatal genetics. And for moderating this panel, I'm inviting Dr. Prateek Tambe sir He is a well-known personality with so many awards and so many publications, and a chairperson, MOGS Endocrine Committee. And also I'm inviting Dr. Niharika Tyagi. She is MBBS, MS, FMA's gold medalist, consultant in fertility and fetal medicine, head of fetal medicine and HRP unit, Javitri Hospital, fellow in fetal medicine, Chennai, fellowship in critical care obstetrics, Safdarjung Hospital, trained in high-risk pregnancy, SR certified embryologist, and executive member of SPAR, joint treasurer, UPCOG 2023. So I hand over mic to Dr. Pratik Tambe sir and Dr. Niharika for inviting their panelists. Thank you.
Let me begin by thanking the ISAR office bearers and office bearers of LP ISAR. I think we started a little late, so we'll try and introduce our panelists very quickly in a short time. First and foremost, we have Dr. Manish Pandya, a dear friend. He is being awarded several fantastic awards. Dynamic Indian of the Millennium by KG Foundation, Gynec Excellence Award by Foxy in 2020, Commendable Editor-in-Chief of the Jogi. Thank you very much, Dr. Manish, for being here. I think he's been here since quite some time throughout the entire length and breadth of the program. We also have other panelists. Dr. Manoj Chalani is, of course, a member of the managing committee of ISAR and a well-known infertility specialist. We also have with us Dr. Sheetal Punjabi. She is a gold medalist and an IVF specialist who's trained abroad in the USA. Thank you very much for joining us, ma'am. We also have Dr. Sheetal Jindal, and she's a senior fertility consultant from Chandigarh, more than 50 years of experience in infertility. And she's a co-convener for the SIG of Applied Genetics for the Indian Fertility Society. I'm sure she will have very much key insights to contribute in today's event. We are also privileged to have with us Dr. Preeti Parekh Thomas. She is an MD from KM in Mumbai. She has also done her fellowship in fetal medicine from Chennai. She is a gold medalist both at UG and PG. So it's a little scary for me to moderate a panel with such distinguished panels, but I hope I'll be equal to the task. Thank you very much and welcome. We also have with us Dr. Ishani Manuche. I think she's one of the few embryologists on the panel. She is from Jabalpur, head of the Ideal Molecular RNA DNA Diagnostic Lab, and she's also faculty for training and academic wing at Ideal. She is a BSc in medical biotechnology in emerging fields. I'm sure she'll have a lot of excellent insights. And I think the final panelist is Dr. Shatabdi Dey. She is somebody who is from Nova, and she has a fellowship in reproductive as well. She's convener the Public Awareness Committee of Fox.
Good evening, sir.
So without further ado, I will hand over to Dr. Niharika to share the screen. She's worked very hard on the entire panel and she's worked on creating the cases. A lot of discussion has already happened previously in the 3 excellent talks that we've had. This will be more or less a revision and problem solving.
You're not able to share your screen, Niharika?
I'm not getting the option of share screen.
You'll need to be made a
Hello,
host.
Niharika?
Yeah, hello? Am I audible?
Support you will need to make Madam the host.
You're audible.
Yeah, so I don't have a screen sharing option coming.
So the INTAS technical team, I think Dr. Monica is coordinating.
Niharika, you can share your screen now. You have been made host.
I does not look like.
Just refresh it.
You're muted, Niharika?
No, we are able. No. We can hear you.
We can hear her, but in the list of participants, there is no host next to her name, which means she's still not host.
Mr. Ronak, can you help it out?
What is the issue, sir?
Dr.
The issue is that the moderator is not able to share their screen, so the panel cannot start. Until then, thoda chai pee let's
All right, I'll just make her the co-host. Just 1 second.
Yeah.
I'm not getting.
Yeah, Niharika, just wait a few seconds. He will be doing it.
Yeah, sure, sir.
In the meantime, I think, Dr. Pratik, you can start an introduction of your first case, I think.
Ma'am, please try sharing your screen now.
Yeah.
So welcome to our panel. Let's try and keep it practical and focused. We don't want to talk too much about theory because theory is quite boring for people. So everything that we've learned so far from the esteemed speakers, we'll try and put into clinical practice. The first case is actually a case of azoospermia. And this is a couple who's married since 9 years. They have primary infertility. The wife is 33 years old. Everything is fine with the wife. Husband has azoospermia on multiple different tests. In fact, his semen analysis shows that there are 3 different reports from 3 different centers, all showing nil sperm.
Tessa, Mesa, and ultimately, if you are very able to do it, you have got multiple of Pesa. You understand? Tessa, Mesa, and then it will give you more Pesa. Because nobody is doing and you are doing the things. So we have to counsel them that we may get the normal sperm from your testes. We may fertilize your wife ovum with this looking normal sperm, because we can't go deep into the genetics of that Y chromosome deletion. Once we see good looking, handsome sperm is going here and there. And as Indrani Madam rightly said, we can pick up that normal looking sperm and we will inject. And hopefully that this sperm might be normal, sir. But now with azoospermia patient, don't give them the first option of donor semen. We have to give them the different basket of options. And if nothing is fruitful, then we have to give them the option of donor semen.
Thank you. Thank you very much, sir. Dr. Sheetal Jindal, ma'am, I would like to bring you here into the discussion and ask you, before you proceed with stimulating the wife with a lot of gonadotropin therapy, subjecting her to an entire IVF cycle, is there any role of doing a trial TSA or a testicular biopsy on the male partner to examine whether there is spermatogenic arrest, whether there is some kind of spermatogenesis actually happening in the testes?
No, I think we do not, as a practice, we do not do a trial TZ. And it is, we straight away take the patients on the day of the pickup of the wife and do the direct micro TZ only.
Okay. Any
And
difference?
it does depend on, so just I would like to add, usually counseling, so number one, in case there's an azoospermia, 2 things we have to rule out. First is there can be quite a good possibility of Klinefelters also, but yes, here we are dealing with a case of 5 microdeletion. So it depends. So it is a PCR based test which we do, and depending on the FSH levels and the type of microdeletion we get, we can always point out that what type of spermatogenesis is occurring. So if the FSH levels are very high, usually it is the AZF-A or B regions of the Y chromosome which are deleted. And in those cases, it is most likely a Sertoli cell syndrome which is there, or a hyperspermatogenesis which is there. So in such cases, getting sperms in micro-TZ would become a little difficult. So the chances of sperm retrieval are on the lesser side, maybe, and these are the cases where you have to counsel them well in advance that we might have to shift to donor sperms in case that the couple still wants to proceed with IVF the next C. But in case but yes, in case it is AZFC, which we usually are able to get in the report, yes, there are good chances, approximately 50% chances that you would be able to get sperms in micro-TZ.
Thank you for that insight, ma'am. I think Manish sir has raised his hand again. He raised both hands, in fact. Yes, sir.
Pratik sir, before stimulating this type of female, the trial, it is not an TSA, it is a trial TSA. And whenever we get the normal sperm, we have to freeze that sperm and we can use that sperm during her IVF cycle. So when at that time we are sure that we can get the sperm. And at the time of pickup also, we can get the fresh sperm also. But
so what is the advantage of doing a trial TSA?
Trial TSA, we can
besides getting sperm and seminiferous tubules, which you are freezing, as you rightly pointed out, there is one more advantage. Kya hoga? As we said, we live in a patriarchal society where the mindset of the male is nothing is wrong with me. You need to have a tissue diagnosis. So if you get a tissue diagnosis from an independent histopathologist that there is spermatogenic arrest, there is Klinefelter, or there is absent Sertoli cell syndrome, then that gives him a tissue diagnosis, which is a report which is independently verified by another clinician. So that adds, and therefore, when you're doing your IVF-ICSI at that point, when you find that this particular sperm is not suitable for ICSI, then they are more readily able to accept the donor sperm option. Correct me if I'm wrong.
I think
Sir, one thing I would like to add,
So if there's complete Y chromosome deletion, then we'll go for like donor. And if there's balanced translocation, we'll see the other genetic causes also.
Yes, sir. We'll come to translocation in the next case. I thought we'll just tackle male fertility because it's a very common issue and we don't really discuss it all that.
So, Pratik sir, I would like to add, doing a
Yes, ma'am.
pre-TSA and freezing it, it actually helps us. Number one, not every patient will be readily accepting to do donor sperm on the day 0 of
Exactly.
pickup. And secondly, they usually, the day of pickup, it is especially with the men, when they know they're going to go for a TISA or they have a difficult sample processing going to happen, they have some kind of psychological fever. They tend to be very nervous and they have a lot of anxiety issues. So I had people dropping out on the days of pickup. So we made a protocol of doing an azoospermia patient to do a TISA before and freezing the sample. It can be different for other places also.
I would just differ from Niharika in, I mean, you know, because it is very difficult to undergo two procedures.
No, no, no.
You do a trial TZ before.
No, it is not a trial TSA. It is a trial TSA with, if we find good sperm, it is a freezing. It is not just a diagnostic.
Yes,
it is just like diagnostic and operative laparoscopy.
So let me summarize what we have discussed. There are advantages and disadvantages to both approaches. The advantages with a trial TSA or a testicular biopsy are that you get sperm, you can have a tissue diagnosis. The disadvantage is that because the blood-testis barrier is breached, there is a greater incidence of anti-sperm antibodies, though theoretical, and later on, whatever little meager sperm you are getting, those also may get destroyed. That's a theoretical possibility that has to be kept in mind.
Yeah.
The importance is that when you counsel the patient appropriately and they've made an informed choice, then they are also partners in the decision-making process. We have now transitioned from an area where doctor was in inverted commas God and doctor used to take all the decisions for the couple. Today's patients are very smartphone friendly. There is a beautiful device called smartphone which they are glued to 24 hours a day, 7 days a week. They can easily find out what is wrong with them and they can always sue you tomorrow saying that you didn't give them a choice or you didn't give an option. I think Dr. Sheetal Punjabi is here with us. She wants to add something. Please, ma'am, go ahead.
Yeah, so same thing I wanted to share, like the way Dr. Mani shared, that it is better to check for the testicular response beforehand, so that like, as you said, like we have a tissue diagnosis and the patients are like, you know, we can counsel the patient very well. Otherwise, at the day of pickup, if we do not find the sperms, then the radars will open up and they will think of like, okay, you have done something wrong with us. So it is always better. And like, you know, in my practice, what I do is like when I do all this stuff, I do a video consent of this patient, because nowadays it is very, very important that we give a right diagnosis, right tissue diagnosis, and we do video counseling and video consent, such that when we are like, you know, if we do not find the sperms and we are using that frozen sperm, we are like we are not at, you know, like legally we are safe, we can say. And second, like it becomes very easy for counseling and then going ahead. So that is second thing. Third thing which I wanted to share is like in patients of like, you know, oligospermia, usually like it is my practice, so it is clinical, but my practice is to take history properly. If somebody has suffered from mumps or orchitis or something, we can give them an answer that why this is so. Definitely we are talking about genetic right now, but in case of like obstructive azoospermia with very high FSH, when they have very high expectation from us, it will create some magic. At least this mumps or orchitis and a very high level of serum FSH helps us to do a proper counseling of those couples. So that's what I wanted to say.
Thank you, ma'am. I think those are very important and practical insights. We spent a lot of time on this male factor and obstructive/non-obstructive/Y chromosome microdeletion case. I'll ask Niharika to take us through the next case, please. Are you there? I think she's facing some issues with her network.
Yeah, so now that we've done with male infertility, we'll come to a very burning topic of doing couple screening. So there is a 30 years old woman, her 35 years old husband, and both are phenotypically normal. They are non-consanguineous. They have referred to you for 5 years of secondary infertility. There are 3 consecutive spontaneous abortion.
And none of these abortions have been cytogenically examined. All the three have been less than 6 weeks, ranging from 5 to 6 weeks. Now, the wife's gynecological examination is normal. Husband has no abnormality. There is a beautiful semen analysis report that he has with him. And there is no history of abnormal pregnancy in the pedigree also. So, can I ask the support team to share my screen?
Yes, ma'am, your screen is being shared. Can you just please tell me the page number that you want me to go?
Yeah. 17. Slide number 17. Can you please pop up slide number 17?
Sure, ma'am. Is this the correct slide?
I can't see it actually.
Is it visible now, ma'am?
Yeah. Now, is it visible to
I
everyone?
think you'll have to skip to the second
No,
case
I think it's
with
not
the
visible.
pedigree
No,
chart.
this is not
Thoda
Yeah,
आगे
yeah.
जाना
So,
पड़ेगा.
come to slide number 25.
All right,
25.
ma'am.
Yeah.
Yes, now it's proper. Yeah.
Yes. Okay. So she's a 30 years old woman with and the husband is 35. Both are phenotypically normal, non-consanguineous. The important part of the history is that 3 consecutive spontaneous abortion at 5 to 6 weeks. They have a normal report, an ultrasound and semen analysis. Next slide, please. So this is the pedigree of the couple. Yeah. Next slide, slide 28. So what are the tests, sir? Prateek, sir, please direct the question to our panelists, sir.
Yeah, so I think we'll start with Sheetal. And again, these are practical questions. Somebody who's had 3 miscarriages, what is the common workup that you would think of? We are not going to talk about endocrine causes like TSH, prolactin, वो सब तो जाने दो. Since
Yeah,
our focus
but
is
I think,
mainly on
yeah.
genetic,
So
do you
I'll
want to
straight-
inquire into the abortus karyotype if it has been done, or do you want to straight away go with the karyotyping of both partners?
I think yeah, apart from Apland also I'm not touching. So straight away we are coming to the genetic causes. Yes, in this case, see, number one, we are not doing fetal karyotype at this point of time. So whatever we are sending is mostly a microarray. And followed by if it is a current loss, then followed by the karyotype of both the partners, just to rule out balanced translocations or numerical chromosomal abnormalities. And in this, as far as this fetal microarray is concerned, yes, to my experience, it does help in pacifying the couple who is in grief. They sometimes, if you're able to find out some abnormality, at least it helps. The ease of the counseling is always there. And plus, sometimes whatever sometimes the report which we are getting, it may throw some light on as to if the parents would be carriers of any would have any balanced translocations or something like that. So usually in our practice, yes, we.
Can I ask Dr. Shatabdi ma'am to
Yes,
contribute
sir.
a little here? Do you do CGS microarray for the abortus tissue when you do your DNC or your evacuation? And how often have you seen that it returns a positive result? Most of the time when I do any karyotype test, it says tissue specimen microarray or insufficient or destroyed or not suitable for analysis, some rubbish like this, which is very annoying to you as a clinician. What is your
Absolutely.
experience?
Sir, similar to what you're saying, sir. I don't prefer doing this POC karyotype so much, because 99% of the times, whenever I used to do it earlier, but 99% of the times I will get a report as you said, tissue is lysed or insufficient for analysis. So I just think it is a waste of money, waste of time, and maybe the patient is also somewhere. We are giving some false aspirations, hopes to the patient also, the couple also, that we will get
But we
something
cannot
out
not
of
do
this.
it because it is prescribed in the books. It's part of standard guidelines, and therefore we have to go through the entire process. But at the same time, I think we need to manage the couple's expectations as well.
Yes.
and tell them that it may not
Absolutely, sir. I would prefer
return the
doing the
result that
parental
we
only, sir.
want. So let's focus now on the
Yes,
parental
I would prefer
karyotype.
doing the parental karyotype.
Thank you. So I'm going to ask Dr. Preeti here, when you do the parental karyotype, especially in the clinical
next
setting,
slide,
where
please.
the couples have had multiple miscarriages, maybe 2 or 3, all of them are first trimester losses. There may or may not have been a POC karyotype done in the past. How often do you encounter that there are abnormalities in the karyotype of the parents? And how do you go about counseling them further? Dr. Preeti, please.
Okay, so can I add a bit to the discussion which
Of
was
course,
just
ma'am. Yes, of course. Please go.
is that when we talk about products of conception, we have to remember that essentially it is dead tissue. I mean, by the time we diagnose that it's a miscarriage or something like that, the tissue is essentially dead. So if we order a karyotype, for the karyotype to happen, the cells have to grow in culture and the DNA has to be isolated. So because these are dead cells, the karyotype is not going to work for these, for the products of conception. So initially when microarray was not very much in vogue, what you could order was a FISH or a QFPCR, which would just give you basic information about chromosome 13, 18, 21, and so on. But now that we have chromosomal microarray, it is therefore the test of choice for products of conception. Again, the things to remember, so the microarray will give you information on the entire karyotype. It will give you information on common deletions and duplications. But we have to remember that the sample which has collected has to be a clean sample. If there is again maternal contamination, then there can be issues with the reporting. Having said that, it is wise to get microarray done, simply because one is that it gives closure to the patient as to why the miscarriage happened, and as we have discussed that if you see something in the POC karyotype, in the POC array, then you can go on and order investigation for the husband and wife. So yes, it does
Thank you,
have.
ma'am. Beautifully put, and I think you balanced the entire concepts very beautifully. I'm going to invite Dr. Ishani here, and from your experience, ma'am, is it typically the aneuploidies which are in preponderance, or it's those rare translocations which are more in preponderance when you examine such couples?
That's a very good question. Actually, in our experience, see, I completely agree with Preeti ma'am here that there is a lot more development that has happened from before, and in our clinics, most of the time the first thing is to suspect some kind of major aneuploidies. But the important point is to further look deeper into the story as to where things are happening. Maybe it's not the fetus that is in the problem. So as Shatabdi ma'am says, parental karyotype, and on top of that any kind of other again micro deletions or any micro array findings, those things are usually missed, and those are the things that might sometimes cause issues. So instead of looking only on the surface level and only on like the major QFPCR levels, it's important to further go and see whether there is some kind of a hidden problem, and that makes it even easier to counsel the patients and kind of even streamline the treatment modalities if they wish to further continue the journey with us.
Okay. So now let's go to Dr. Manoj Chelani, sir. Sir, let us consider that this couple, maybe one of the parents has a translocation, which is being inherited into the fetus every time. So would PGT be an option in such a couple, assuming that finances are not an issue? In an ideal condition, in an ideal world, would you offer PGT to such a couple? And how would you go about counseling them for it?
The problem with the PGT is like there will be around 18 possible outcomes. So you need a good number of embryos also. And second thing is it's costly also. So these are certain things we have to keep in mind, looking at her age and other things. So that thing I think is very, very important when you counsel her.
Sir, I would like to add something here, sir.
Hello.
Am I audible? Am I audible?
Yes, yes.
Yes, yes, yes.
So, sir, she already has a miscarriage. Her age is in 30s, so we can't just, and the number of embryos expected from her will be less. So I don't think it will be very fruitful to go for PGT in this case.
No, I think it will totally depend on her AMH levels, and PGT should be an option which should be discussed with the patient. The only thing in PGT we have to tell her that it could be the same balanced translocation which might come in the embryo. So that is one thing. And plus we have to reassure her in case the karyotype is normal, parental karyotype is normal, that she still has a 50% chance of getting a normal baby further. So it's not straight away an IVF always with previous 3 abortions.
Right.
We have to investigate.
There are many possibilities are there.
Which can be there. And in
Yes,
case, so just after 3 abortions, straight away IVF, I would probably disagree to it.
No, what I was saying was, in case you do a parental karyotype and you found that there is a translocation in one of the parents.
Right, sir, right.
If mother is a carrier, we can advise a oocyte donation. If a father is a carrier, we can advise sperm donation. So that can be.
So sorry, I think the voice was not audible.
PGT karna hi nahi hai main. It's too expensive and we can't afford. That's why I put that clause in my question, that assuming that this is an ideal case scenario, we're practicing in a situation where finances are not an issue, where the couple want their own genetic progeny and they don't want the option of oocyte or sperm donation. Manish Pandya sir is raising.
In that case, obviously. In that case, In that case, obviously.
Sir, this is a report of POC done 14 days back.
Yes, sir.
So it shows trisomy 21. It is a POC product. Patient has got 3 abortions. So just I am differing little bit. If there is a clean sample, wash sample, put it in a normal saline with gentamicin, transported properly, cell cultured properly, you will get the report. Irony of situation, when report comes normal, then we cannot explain. If report comes like
then you
this,
have to try again until you succeed. Then you don't have any other option.
So once there is a trisomy 21 like this, we will advise couple to go for their parental karyotyping. And believe me, 50% trisomy 21 couple karyotype is normal.
Normal, yes.
So it is not certain that with 3 consecutive abortion, it is advisable to do POCs because something related with the crop. If
yes, your point is well taken.
Crop, so we can give them the good diagnosis, and good collected POC will give you very good result. So I am sending it regularly with the genetic lab, and you can find this abnormal report also. So once abnormal, we can go for parental karyotyping. If parental karyotyping abnormal, we can go for PGD. And now you see PGD is not like rocket science. Every center, they are doing that blastomeria biopsy or trophectoderm biopsy. We are selecting good embryos and we are giving them the chance of 100%. And now you had already said patient has got smartphone, patient has got Google. Google is serving like a god to them and to us also. So you have to believe that God is creator, generator, and destroyer. So we have to believe in that Google also. So we have to give them all the possibilities. Thank you.
Sir. I think you have expressed it beautifully.
Presuming the wife has a balanced translocation, we would like to go ahead with this case scenario that the husband is a normal karyotype, but the wife has a balanced translocation for trisomy 21. So what will be the fertility option and why we are choosing that? Sir, would you like to direct this question, sir?
Dr. Preeti and Dr. Ishani, I would love to hear from both of you because you've been quiet on this scenario so far.
So, well, if the wife has a translocation involving chromosome 21, then it can either be with some other autosome or it can be a 21-21 translocation. In case it is a 21-21 translocation, then we say that 100% of pregnancies are going to be affected with Down syndrome, and therefore the scenario of change of gametes should be discussed with the couple.
Very practical and very clear. Thank you.
If it is a translocation with any other autosome, then the couple can be given the option of going ahead with a pregnancy with their own gametes or a donor gamete, fully understanding the fact that this translocation can become unbalanced in the fetus. The fetus could inherit a balanced translocation and therefore could be euploid. Or if the fetus inherits an unbalanced translocation, then definitely there can be consequences. So this patient definitely has to undergo a prenatal invasive testing in the form of an amniocentesis at 16 weeks.
It's
Thank
quite
you, ma'am.
important.
Is Randir sir around? I wanted to ask him what is all this PGT business, because this has come in quite recently and I'm not very much aware of PGT-A, PGT-B, PGT-S. This is kya hota hai? What is all this? Why are they confusing us so much by changing terminology every couple of years? Does anybody want to take it? For the benefit of old timers and ordinary people who are there in the audience, if you
I
could
think
please
Ishani
explain.
can take it and tell us.
So
Ishani?
Dr. Banerjee, Dr. Dipankar Banerjee explained very
Already
well on
explained
the
very
whiteboard.
Already explained. Actually,
But it was very far away, no? You couldn't see it.
Shani, you can explain better. Because
Before earlier when I started studying.
I'm still with you, Pratik.
Yes, sir. Good evening, sir. Sorry, we're just cracking a little jokes at the end of the program.
Dr. Pratik, you know, na, Ishani is Dipankar sir's daughter.
I know, I'm aware.
I actually
I've been listening to the whole program.
we set up the whole the whole set to kind of just hoping that something is visible. So
I know, वो थोड़ा लंबा था तो मैं दिखाई नहीं
so I have to train him to start using an
नहीं
iPad.
सर मुंबई में बैठे ना इसलिए नहीं देख पाए थे वहाँ होते तो देख ले
कोई नहीं. I think she's the perfect person to tell us what is this PGT A, B, M, all this business. ये क्या होता है?
To summarize the earlier talk which my father has given. So earlier when I started studying genetics and it used to be PGT, PGS and PGD, right?
Yes,
So
absolutely.
we started from there and then every 5 years, 4 or 5 years, the terminology started shifting as
Correct.
figuring out things more in detail. So PGT-A is, it's just basically your, their acronyms. If you're looking for any aneuploidies, it's PGT-A. That's mainly your Edwards, Patau's, Down syndrome, any kind of other aneuploidies, balanced, unbalanced. PGT-M is monogenic, where you're looking at monogenic disorders. That is mostly seen by looking at, array CGH or sequencing techniques. You're looking at single gene disorders, Mendelian disorders.
For which the gene probes have to be individualized and which are prohibitively expensive.
In PGT-M case, you need to know what you're looking for. That is one caveat. Because otherwise it becomes like a needle in a haystack, or it becomes like the most weirdest report that comes is VOUS, variants of uncertain significance. That is where we get stuck every time. So PGT-M is a little bit more, and PGT-SR or structural rearrangements is, chromosomal major inversions or deletions, or very small micro deletions and micro substitutions, which happen inside in you can see either in the karyotype, or you have to go for microarrays to look at the structural rearrangements. These structural rearrangements also can, you have to know how big of a rearrangement you're looking at. So in that case, you'll be able to decide what tests to go for. And these menus, like as Dr. Manish has also pointed out, you have to give these options, all these options available to the patient. Otherwise, either they'll say, "Humme bataya nahi," or they won't know what to do. And most of the time, they'll come and say, "Humme bataya nahi." So it's better to give them all the options.
So,
So can I ask? Yes, ma'am. Go ahead.
Yeah, so we did going further with this PGT-SR, the fancy thing that we did 4 trophectoderm biopsy in this balanced translocation of 21 and 13. Out of which 1 embryo was actually euploidic. Rest of the 2 had a chromosome 17 and 21 10 aberration. The first one had multiple gains and losses, so that was a very chaotic embryo. And this was the summary of those 5 blasts that was biopsied. So what is the role of genetic counseling? I think
So before we come to genetic counseling, I wanted to ask another practical question, which come to genetic counseling just in 1 minute. Dr. Sheetal ma'am, is it possible that your biopsy may actually be wrong? It may turn up to show that there is something wrong with the embryo, but the embryo is actually normal and you're discarding a good embryo. ऐसा भी होता है?
So I think the concordance rate nowadays is very, very high. with the PGTM. So if you see the, especially, I'm talking in general about PGT. So till date, the misdiagnosis, what they quote is just 2%. And the HEFA results till now have not even found a single embryo with any misdiagnosis. So, and
Yes, sir, of course, sir.
and can you just say what exactly you want me to tell?
Basically, mosaicism is something which is very common in the initial stages of embryonic life, and it is quite possible that there may be sampling errors, and you can have false positive as well as false negative, and that's why we need to be careful when we interpret the results.
Sir, I would like obviously the type, the technique of the biopsy definitely matters. So from that perspective, there can be a lot of segmental errors and all these, mosaics, what all we see, it totally, so a lot of chaotic embryos could be because of, the
exactly.
It's
not 100% concordant.
That is all I can say.
Yes, sir, please go ahead.
Pratik, you are asking a very important and pertinent question being a gynecologist. And your question is very to the point that either we are discarding good embryos in the notion that the results are wrong. But there are two things which are very important. You are talking about infertile couple. Here PGTM is a fertile couple selecting an embryo with disease-free embryo.
Yeah.
So PGTA is a different thing where baby is not happening and you are selecting a good embryo and non-aneuploid. Where if you do an aneuploidy test where the husband wife they are infertile, now you are selecting an embryo by doing a trophoblastin biopsy, which might not be a good concordant result with the inner cell mass which makes the baby. Regarding the mosaicism, when you do a trophoblastin biopsy, there are a number of problems from the lab also. When you use laser, you destroy the nucleus also. So that might create a chaotic result in the report. So what happens in the world that there are two groups of now thought. One is totally discarding, that is, if you go Norbert Gleicher's class in USA, they say this is a dead end, don't do it. But there are people, if you go with the other American areas, that they somewhere now force people to do PGTA because there's a part of the practice. So we have to be very careful about for what we are doing pre-implantation genetic test. Are we doing for infertile patient or are we preventing the disease in a fertile group?
Thank you, sir. I think you put it very beautifully, and in the light of how science is advancing, we have to remember that no technique is perfect, and every new year brings more and more advances, more refinements to our techniques.
And one thing I want to add, when we have these thalassemia major patients having pre-implantation genetic test, you take very tiny amount of cell, and these cells you have to amplify the gene or DNA. When you do any photocopy of a paper of a book, you might do some.
I think we've lost sir, unfortunately.
Yeah, we lost him. Yeah.
Can we have Dr. Manish Pandya with his own unique perspective? Genetic counseling practically कैसे करते हैं और patient को क्या बताएं?
नहीं sir जी, I want to highlight one thing. Just you say PGD had advanced from PGD to AMD SR. Like we have evolved ourselves into the taking biopsy also. So previously when we are doing only PGD, we are dating more and more negative reports. But with the evolution of science and evolution of the technology, understanding of the biopsy, how to take it, where to laserize the cell so you can get the less damaged cell, and how to send it to the laboratory. It is also utmost important in which vial you are sending and you have to enable the vial. So many times you had rightly pointed out that normal looking embryo can give the abnormal result. So we are not discarding that normal looking embryo. We are just skipping it. If she doesn't become pregnant, we are telling that this is 50% abnormal embryo. We are putting in a second cycle, and believe me, it turned out to be a normal baby.
Yes, that is also possible because of
the
mosaicism.
irony of situation, but we have to think that nature has got its own corrective mechanism, but we are giving them the good options. So as a gynecologist, we have to tell them that we are doing the best, but we are not the best. Best is the ultimate God.
So I think we've exceeded our time. We'll just have one simple take-home message
yes, sir.
from
Hello.
Yes, we lost
Yeah.
Pratik, sir.
So we'll just have a very short brief for the genetic counseling. We have all counseled regarding that how the embryos will be tested and all that. What basically that involves is that family and partner should be taken into consideration both. Before doing an SR, always go for a couple karyotype, and to how do you actually predict the result is not depending on the type of the it's not actually just on the type of the biopsy technique, but it is basically also regarding that when we say healthy, we are supposed to tell that this does not mean that the blastocyst is a completely haploidic. It can be a balanced translocation like the mother herself. And also we need to test for a uniparental disomy testing to be done in these cases of Robertson translocation. So last but not the least, we have to tell that post-test counseling that there is no guarantee that even if you are putting a healthy embryo inside the womb, she will have a positive pregnancy test, and we have to counsel for the pregnancy workflow. So can we have Dr. Preeti, who can just tell us how do you go ahead with the pregnancy of a PGT-SR patient?
I think any patient who has undergone a PGT, so I come into the picture only after the patient has conceived and comes for her early pregnancy or NT scan. So all those who have undergone any testing, it is always, we always offer a prenatal testing. Of course, these patients have to undergo very detailed scan. We have to make them understand that, there can be implications, even though the results were normal, we always have to check in the prenatal whether the type is normal or not. So these couples do require a lot of time and hand holding and counseling and questions back and forth for them to understand the implications of genetic.
So in one word, will you go for a non-invasive prenatal screening, or will you go for an amniocentesis and see her karyotype?
We always prefer an amniocentesis.
Perfect. That's perfect. So, Ishani, what are the limitations of PGTs in these cases, and what are the challenges faced? Dr. Manish sir and anyone else? Dr. Manoj sir, could you put up your inputs regarding how do you?
Yeah, I already mentioned that you need large number of cells, embryos, first of all, viable embryos, and secondly, cost is also an important factor.
We might not get even a single normal embryo. That is the biggest limitation.
Yes. That's
you may not get a single normal, right?
Very important to tell the patient. So basically, like sir had said, for the chaotic embryos, they are mostly commonly seen when we do a day 3 biopsy. And eventually, if you do the respective biopsy on day 5, they don't turn out to be as mosaic. Rates are lower when it comes to day 5, and 99% of us are doing a day 5 biopsy. Also, we have to understand there is a technology limitation now that with the lower coverage of NGS sequencing that has been done, so you have an allele dropout and drop in these cases. Also, trained embryologists are very important in doing a biopsy, like Sir Pankaj sir, Banerjee sir has already said. You have to send a sample to a validated genetic lab. Now, every right and left, we have more than an iron calcium company. Up to genetic lab ka prachar aur prasar aata hai OPD mein ki everybody is doing in 7,000, 8,000. Matlab, you name the price. So you need to have a very validated genetic lab that you should have. Now, logistic issue is something that we face on a regular basis. Ki logistic mein when you send the sample, how do you send it? How do you make sure that the sample sending is smooth between you and the company? Sir, would you like to add on this?
Can I ask one question? Whosoever is doing trophoectoderm biopsy is a placental biopsy, and any test from the placenta, like in NIPT, have we take this NIPT result as a final result, because it is a screening result? My question is very simple, and should we take that test from the placental cells to discard a good looking blastocyst when we don't discard the baby without doing any invasive test?
Sir, in a structural re-abnormality, I don't think so. We should take a chance when the functional is suggesting some kind of.
If it is with structural rearrangement, I withdraw. I take back my.
Yeah, for a PGTA, sir, I don't think so.
PGTA is
Mosaic embryo,
controversial,
people are
sir.
discarding.
PGTA is controversial.
Yeah.
I mean, that is there.
On a 20% mosaic, I don't think anybody is
in terms of
discarding.
aneuploidies, I think morphological evaluation should be a part of the screening process, and just discarding the embryo based on chaotic aneuploidies
No,
from
I
the
don't think
profile
nobody is
photo.
discarding on the basis of a mosaicism. If it is 20 or even 25, we do according to the recommendation that is given to us. So usually if it is a single mosaicism of around 20-25%, we go ahead and we transfer it and give it a ANC checkup like a normal pregnancy. We don't even do an invasive testing in these kind of
So I
patients.
think close supervision, antenatal screening, ensuring that you have a good first and second trimester screening set up in place where the patient is referred appropriately is of paramount importance. You can't treat these patients in small local peripheral setups. They need to be in a tertiary care. They need to be in a center of excellence where there is expertise and multidisciplinary care available. I think we'll wind up. So closing remarks from Niharika, and then we'll call it a day and hand over back.
So thank you, Pratik sir, for the panel. So we have all talked about genes, genetics, and everything, and embryology and everything. I just want to go ahead with the few certain one-pointer slides that PGT, or anything that we do, we have to have a good cryopreservation, vitrification. We need to know the technique, better technique, best technique, the knowledge of laser, what is the power, where to shoot, how is your inclination, and how is the angulation of the laser, especially dealing with difficult cases like a completely hatched blastocyst. And also very important is actually witnessing. You have to write the right credentials of the patient, putting the right number, labeling the blast. If you label or your technician labels it wrong, then everything is gone into waste, and you will probably marking a neuploidic embryo as an aneuploidic embryo. So what I want to suggest is that whosoever does the biopsy is the person who should be writing the credentials as well as labeling their blastocysts. Also, inadequate sampling is something that is very frustrating for the clinician as well as the embryologist. And in the end, I would just like to say, we'll not go with the third case, which is a very short case, but we are overly exceeded our time. Yeah, so like genetics is something that is right and left. हम jeans भी पहनते हैं और jeans के साथ रहते हैं. So
It's a very interesting comment.
Yeah, so we need to understand how our genetic, how much we should actually go into this genetics rather than making a Pamela Anderson and exchanging it with an Arnold Schwarzenegger. And with this designer babies coming into our practice, we need to understand that there will be one day that all of us, including our babies as well as our husbands and wife, all of us can be replaced by these designer labs. So keeping in mind that when we stop, we should limit ourselves with this.
So I think I just want to say one thing. Thank you, Niharika. I mean, just a very important thing about PGT. So PGT is a team effort. So you require a geneticist on board. You require an excellent embryologist, which has good blastulation rates, and along with that, a good fertility expert. Along with that, a fetal medicine specialist. Only and only if your lab is making more than 60% of the blastocysts, then only we should enroll. We should, we should enroll and start the PGT program. And a non-invasive PGT is something which is coming up in a bigger way. Yes, that will reduce the limitations which are there with the learning of the biopsy. And this is something, which is definitely, but then it is still experimental and we have a long way to go.
Yeah.
And Indian Fertility Society, just I wanted to bring down, we have conducted a survey, and probably IFS is trying to get guidelines on PGTA as per the Indian standards, and hopefully by the next IFS in this year 2023 we might be just coming up guidelines for the gender for all the fertility practitioners. So, and thank you so much, Dr. Monica ma'am and Niharika and Isar for giving this opportunity. Thank you, Dr. Pratik. It was very nice just to be part of this whole discussion.
Thank you all,
Thank
our
you.
learned panelists,
like
for
to
being
add,
so practical, precise, and to the point. Thank you very much.
I would
Pratik
like to
sir,
add
one thing
my
I want to
thanks.
say. Hello. Yeah,
Pratik.
Niharika, Pratik, Monica madam, Ishani Banerjee, we thank you. So it is genetics is just like Gita, Bible, and Quran.
बिल्कुल सही.
Everybody has
Yes,
read
yes.
it,
Hard
but
time for
nobody has
Yes,
clinicians
understood it.
to
Everybody has
Yes.
read it, but nobody has understood it.
Understood.
So every
True,
time we
so
have to
true.
create new and new version of Gita, Bible, and Quran. So thank you,
True.
Monica madam, for giving us insight of this genetics.
Yeah,
And
yeah.
I
And
would
thank
like
you.
to add
Before
my-
Thank you, Monica ma'am. Thank you, Ranveer sir.
Before we
Thank you
end,
so much.
my take-home message is that please add PCPNDT always a part of your this activity.
your this thing.
Because, yeah.
अरे ये बात
Sir,
बिल्कुल सही।
ART आ गया है सर
नहीं,
अब तो
मैंने लिखा
ART
था वो
की
ग्रुप
वजह से
में,
अब तो
ग्रुप चैट में मैंने
or
डाला
if
था,
you if you
but
are any
किसी ने
doubt,
देखा
take the
नहीं.
help of Ranveer LLB.
Yeah, always. I'm always there. And MP is the first state to start the surrogacy and all. So we are always there. And this PGT must be shown to all your local appropriate authorities that what you are doing. Yeah.
And I must confess that whatever I wanted to achieve from this webinar, we have achieved 10 times,
Both of us.
10
Oh, yeah.
times more because of you all.
Thank you, madam. Thank you.
Thank you, Monica ma'am, for all your efforts. You really worked hard.
It was wonderful, wonderful. I think the next perfection series is going to Chhattisgarh to Manoj Chilani. And I know Manoj also does a wonderful job, and we have to collect the diamonds from India, because in India there is so much of talent, so much of bright youngsters and veterans and, you know, brilliant people like Pratik. They will bring out the best in us. Thank
I
you
would
so
like to
much.
extend my
Monica
thanks
madam,
to the
thank you.
panel.
Thank you, Pratik sir. Thank you, Dr. Niharika. It was really a great panel. I was too scared with genetics, but really enjoyed this panel.
genetics
Thank
is
you,
scary,
sir.
sir.
And
Very
seeing,
practical inputs.
seeing the Pratik Tambe sir, seeing
you all.
Seeing Pratik Tambe sir background, it's already hi-fi and topic was also hi-fi. So thank you so much.
Yeah, that's
Sitting,
good.
sitting inside a Death Star.
Yeah, and we got all nice information from Preeti, experts, Dr. Banerjee sir, and
Yes.
with the support of the National ISAR President Sunita ma'am, and we wish her that she has, and she is going to win the
ठीक
her
है
elections.
रतीब सर, मोनिका मैम बहुत बार कह रही है कि डायमंड्स ढूंढने पड़ते हैं, पर डायमंड ढूंढने के लिए भी हमारे पास एक अच्छा ज्वेलर होना चाहिए, और वो कहते
तो
हैं
हम लोग
पहचान आप
तो हम लोग हैं ना,
पहचान कौन?
बेटा, हम लोग हैं ना,
पहचान
पंड्या
कौन?
सर हैं, हम लोग हैं ना, सुनीता मैम है, all seniors, all our seniors, we are here.
In this webinar, I was very sure I'm not going to go for big names. I'll have the people who can really give inputs today. Of course, big names are there like Pratik and Sunita Tandurkar. But I knew that Niharika and Preeti and Divya and Doel, they will have fireworks going, So
thank you so much.
It is mission accomplished.
Thank you.
Mission accomplished.
Perfect.
Thank
I
you.
think we've learned more than what we have taught actually.
Yeah.
Yes.
So,
Thank you, sir.
So
Thank
please,
you.
please attend the next webinar of perfection.
Yeah. Please,
on
we'll start.
10th of May, which is on genital tuberculosis. So genital tuberculosis, we are going to deal with everything associated with genital tuberculosis on 10th of May. Thank you so much.
Thank you.
Thank you. Bye-bye. Thank you.
Doyle, it was an excellent presentation. I mean, really learned a lot. Really, it was very simplified. Thank you so much.
Thank you.
Thank you, Monica ma'am. Thank you, Niharika.
Bye.
Thank you, everyone. Thank you.
Bye. Special thanks, Dr. Pratik. Thank you, Vishal.
Thank you,
Thank you,
Monica
Manoj.
ma'am, for
Thank you.
inviting me. Thank you very much. I am standing on the shoulders of giants.
Yeah.
For babies like me, it's a great pleasure to be a part of this. As
Nahin,
from the scientific community.
Ishani, we have seen you kids growing up, so it's
Yes,
such a pleasure.
I never imagined I would be
Such
sitting
a
here with
pleasure
you.
listening to you all, now
Thank
that
you
you
very
all
much.
are, big specialists. It's so nice updating yourselves, listening to you all.
Thank you very much. It's a great honor and great pleasure to be a part of this. Thank you very much.
Thank
Thank you,
Bye.
Pandya sir. Pandya sir,
Thank
bye
you.
sir. Bye.
Thank you. Namaskar.
Pandya
sir.
sir,
Namaskar.
24 मई आपके साथ है, 24 मई.
पक्का
हाँ,
मैडम.
पंड्या सर के साथ है, yeah.
पक्का मैडम कर देंगे. Thank you.
Thank
Bye.
you, sir. Thank you. Bye.
Thank you, Dr. Vishal, for
Thank you, ma'am.
excellent management. बस लास्ट में वो थोड़ा सा अपना स्क्रीन शेयर का कुछ इशू हुआ था.
Yes.
क्या था? There was some technical glitch or Niharika was
It was
not able.
from Niharika madam का screen share नहीं हुआ.
Actually, ma'am, Ronak here from support team.
Yes, yes.
I tried coordinating with ma'am and she was using a browser version of Zoom. So in browser version of Zoom, there are lot many complications while sharing the screen and when viewing the screen as well. I did give her the control as well, but she wasn't able to change the slides as well.
Doesn't matter. But we achieved our goal. I was able
Sure,
to,
ma'am.
the program was going well, you know?
Yeah.
Thank you so much, Ronak. And
Okay.
thank you so
Yeah,
much,
welcome, ma'am.
Vishal.
Welcome.
Tomorrow is one day rest and day after tomorrow, we are starting the 3rd episode.
Okay.
So this is on
Sure, ma'am.
genetic tuberculosis. We are doing after 2 weeks and this is with Chhattisgarh chapter of ISAR. So I will have a program ready in next 3 or 4 days.
Okay, ma'am.
Thank you
Okay.
so much. And I cannot
you.
thank INTAS enough. It has been, great support of you all.
Thank you, ma'am.
Ronak and Dr. Vishal. Thank you so much.
Thank you, ma'am. Thank you.